Everyone says you should learn to code, AI is the future, automation is everywhere, and so on. But what they don't talk about is how overwhelming it feels to start. You open a Python tutorial and it feels like a foreign language. Terms like variables, functions, loops all over the place. It's easy to feel stuck before you even begin. But here's the truth. You don't need a computer science degree to understand code. You don't need to be a math genius. You just need the right starting point. And that's what this crash course is all about. We will go step by step, no jargon, no pressure. Just a clear path to help you finally get comfortable with Python. Whether you want to dive into generative AI, build automations, create tools and applications, or just simply understand the world of tech better, this course gives you that foundation. Real coding, real logic, real results in just one video. So if you have been putting it off or waiting for the right time, this is it. Let's break the fear of programming and finally start creating. Let's learn Python. So this is what we are going to discuss in this course. So first we will discuss about the introduction and setup. We will begin by setting things up, installing Python, choosing an editor, and understanding how Python code actually runs. You will also get a quick introduction to what Python is and why it's widely used. The next one is about Python basics. So we will look at how to store data using variables, the different types of data you can work with, and how to perform basic operations like math, comparison, and more. So here in this Python basic sections, we will discuss about variables, data types, and operators. And then we have control flows where we will discuss about if, else, and conditional logic. So you will learn how to make decisions in your code using if, and else statements, helping your program respond to different situations. So the fourth section will be about loops. So here we will cover for and while loops, essential tools that let your code repeat tasks automatically. And the fifth section that we have is data structure. Here we would discuss about list, tuples, dictionary, and sets. These are Python's built-in data structures. You will learn how to store, access, and organize collections of data effectively. And the sixth section we will be working on is functions. So functions help you to organize your code into reusable blocks. We will write our own functions and learn how to use them like a pro. So the seventh section is about error handling. So here we will be discussing about try and except blocks. Things can go wrong, and that's where error handling comes in. You will learn how to keep your programs from crashing using try and except. The eighth section is about file handling. You will discover how to work with files, reading data from text files and saving output using Python, and so on. So the ninth section will be building a mini project in Python. We will take everything we have learned so far in this crash course and build a simple real world app step by step. And the 10th section would be like what you can do next, like what you can learn, like object oriented programming or AI development or building API for backend and so on. I'll also give you some idea on what are all the other crash courses I'm planning if this particular Python crash course goes well. So that's about that final 10th bonus section. Okay, so let's get started. So the section 1 would be introduction and setup. This would be for us to get started with Python. So what exactly is Python? Python is a high-level beginner-friendly programming language known for its readability and wide range of application. Now, when we say high-level, we simply mean that it's easy for humans to understand. You don't need to worry about how machines understand this code that we write. You just write logic in a way that feels natural. So that's what high-level language is, which is kind of close to the language that we speak. So that is why Python is also like one of the most popular language in the world and kind of a favorite for beginners. So it is easy to read and write, which makes it a great first language. It's also versatile and powerful. So whether you're automating a small task or like building something big or writing code to build some AI agents and so on, Python can handle it. So it's very versatile. It's used by top tech companies like Meta, Amazon, Apple, Netflix, Google, and so on for everything from automation, backend system to AI research and tools. And today, Python is also a major player in generative AI, the technology behind tools like ChatGPT, image generation, smart assistant, etc. And you can also use it as a web framework, backend, API framework, and so on. So if you are excited about AI, apps, automation, or just want to learn how to code, Python is the best place to start. So the next part of this video that we'll be discussing is about installation and setup. So before we start with Python code, let's quickly look at how to set things up. So these are a few great tools that you can use. So here we have Google Collaboratory, shortly known as Colab, and then we have Jupyter Notebooks, and then PyCharm. Google Colab runs entirely in your browser, no installation needed at all. It's great for writing code step by step, just like a Jupyter notebook, but with added feature like free GPUs that Google provides. So you can have that free GPU access and easy sharing through Google Drive. So you can just share the code files that you write, just like you share your Google Docs with Drive. And then we have Jupyter Notebook. So this also lets you run code step by step and see output instantly. So the difference between Colab and Jupyter Notebook is that this one Jupyter runs locally on your computer, which gives you more control over your environment and the install libraries. But for this, we have to do some installations. And then we have PyCharm. PyCharm is a full-featured professional IDE, what we call as integrated development environment. Perfect if you are building complete applications or want smart features like autocomplete or debugger or project management. And apart from this, we also have VS Code, and if you are already comfortable using VS Code, you can write Python there too. Just install the Python extension and you are good to go there. So Colab and Jupyter Notebook are like very useful for beginners, but again, as you move forward, at one point you might have to switch to PyCharm, as it helps you like write this complete code with multiple scripts and modules and so on. But it's much easier to start with Colab and Jupyter Notebook. So we will go through all of these briefly, and you can pick the one that works best for you. So we will just like discuss how we can set these three things up. In this part of the video, I'll show you how to use Google Colab, which is a free and super easy way to run Python code in your browser without installing anything. Google Colab, short for Collaboratory, is a free online platform developed by Google where you can write and run Python code in a Jupyter Notebook environment. It's especially useful for beginners because you don't need to install Python, everything runs on the cloud, and also you can access your code from anywhere, just like Google Docs. It's not confined to your local machine. Let's see how to open it. So open any browser that you are working on and search for Google Colab. So make sure that you are logged into your Google or your Gmail account, so that makes things much easier because all these files that we are working on will be saved in your Google Drive connected with your Google account. So that's the reason. So once I search for this Google Colab after signing in, I will see this link called as collab.research.google.com. So this is the site that we have to go. Welcome to Colab thing. Okay, so let's click this. And here you will see there's a new notebook option. So go ahead and click this. So this is going to create a new notebook file where we are going to write our code. So this may take a few seconds. So let's wait for it. Yeah, it is there. So you see this black colored cell over here, right? So this is where you would write your Python code. Let me show you a quick example. Let's say I'm typing something as print hello world. Okay, so I would say print open and close parenthesis, and let me say hello world. Now before running this, here you will see an option called as connect. So this gets connected to a runtime so that you can execute your code. So first time when you open a notebook, you have to go ahead and connect this, or even if you run this code cell, right, so it automatically connects to it and then it will execute your code. So that's the process. So you can see the connection is in progress, and here you can see like the details of the system that is assigned to you. So as this is running on cloud, we have a 12.7 GB RAM of system and under disk space of like total of 107 GB. So this is a system that kind of got assigned to us. And in the top left corner, you can also like rename this file. Let's say that let's call this getting started with Python. So this is the name of the file, and IPYNB, which stands for Python Notebook, is the file extension, just like the .py, which is the extension for Python scripts. This is what we call as notebooks. So IPYNB is the extension for it. So press enter. So this is the name of the file. And then here we have written print hello world. To run this, you either press this run symbol or you can press shift plus enter. So that's going to execute this cell. So it's just printing this text present within it, and it's going to open a new cell. So again, let me just like copy and run this again. You can also click this run symbol. So this is going to run it, but when you press shift plus enter, that's going to run and create a new cell over here. So just click this plus symbol that you have over here in order to create a new code cell, or you can also click on this text cell, so that's going to add a text cell. So this text cell is used to write some descriptions about the code and some details about it. This is not for executing code, but some descriptions and plain text. Maybe what I'll do is I can also create this before this cell. So before or after, we will see this plus text and plus code thing. So I'll say plus text, so this is going to create a text cell above that. So double click here and type something like Python basics, and again you can press shift plus enter, so that's going to add this. So here you can see this text called as Python basics over here. So you don't need to worry about saving manually. As you can see, it kind of gets saved automatically to your Google Drive. So in case you want to share this notebook or your code that you're working on this, it's much easier. You can just go to this share option. So click this, open this, and you can just like give the person's Gmail address or their any email address, so they would be receiving the access for these files, again just like your Google Docs or Google Sheets and so on. So I recommend Google Colab for beginners because it's beginner friendly. You can run code step by step. As you can see here, you don't need to write and run the entire code at once. You can just like write code step by step and all that. So no setup headaches at all. So you don't have to worry about installing Python like other libraries and so on. Most libraries are already installed in Python. Again, it Colab comes with Python as well. So it's like you don't have that headaches of doing setups. And yes, even you can use it on your phone. And another pro tip is, and later if you move to more advanced projects, you can even use free GPUs for AI, machine learning and deep learning experiments right inside this Colab. So in this runtime, if you go to this change runtime type, you have this option to connect to a GPU or TPU and so on. We will come to that later, but yeah, later you also have this option to connect to a GPU environment instead of a CPU environment. So that's like another advantage that we have. So that's a quick overview of Google Colab. So we'll be using this a lot in our Python crash course, so you can follow along easily. So in the next step, let's understand how we can set up Jupyter Notebook and Python in our machine. Next up, Jupyter Notebook. It's very similar to Google Colab. You write code in cells, run it step by step, and see the output instantly. But unlike Colab, which runs in the cloud, Jupyter runs locally on your computer, which gives you full control over your environment, which is why it's often preferred in companies and professional settings. To use it, you will need to install Python first and then install Jupyter Notebook or Jupyter Lab using Python's package manager. It's a very simple process. Once that's done, you can launch it right from your terminal and start coding in your browser, just like Colab but fully offline. Jupyter is also widely used by data scientists and developers, and it's a great option if you prefer working on your own system. Let's get started with Jupyter Notebook. Okay, so the first thing that we need to do, as I said, is install Python. So go to Google and search for install Python, and you will see this python.org downloads. So you can go to this download Python, and this is the latest stable version. So you can just download this 3.13.5 version. So it's a very small file. So it's like 27.5 MB of size. So open it. So I'm opening this thing. Let me minimize the browser. Okay, so here we have to give install now, but before that, make sure that you add python.exe to path. This is very important. So only if you do this, you can access the Python thing from your terminal. If not, we have to add it to the path and the environment variable. So it becomes a bit tricky, but just in the installation, make sure that you are adding this python.exe to path, and use admin privileges when installing py.exe. So if you have admin access, you can just like give this thing as well. If not, if you are just running it on users, probably shouldn't do it. But yeah, if you are using it in your personal machine, you can just like give this admin privileges. So I'm going to give this install now options, and it's installing Python in my machine. So make sure that you have selected that adding path python.exe to the path. So let's wait for this installation to complete. So this shouldn't take like a longer time. Okay, so once the setup was successful, you can just like give this close, and like that is all we have to do. It's like the installation is like pretty simple. So once that's done, we can open our PowerShell. So I'm going to the search bar and searching for PowerShell here. Okay, so this is my terminal. So this is the user that I'm currently in. So I'm going to say python space double hyphen version. So it says Python 3.13.5. So this is what we have installed right now. So if you should see this version, if you're not seeing that, that means the installation didn't happen properly. And one issue might be, as I said, like it may not have been added to path. So that's one thing. You can also check the pip version as well, which gives you the version of pip. So pip is used to install libraries. So Python comes with several third-party libraries and inbuilt libraries as well. So if you want to install some libraries, you can use this pip install. So we need pip for that as well. And this will be installed like when you install Python. So Python is the main requirement over here. Okay, so this is the first step. So now let's say that we want to install Jupyter Notebook or Jupyter Lab. Jupyter Notebook is again similar to Colab with like all those notebook things and all that. Jupyter Lab, it's kind of gives you an option to work with terminals, files, folders, and so on. So it's like a bit easier. So I'll show you how you can install both. So you have to give these commands in your terminal. So say pip install space Jupyter Jupyter. So that's the spelling. So run this. So this is going to install Jupyter on your machine. So let's wait for this installation to get complete. Okay, so this took like 2 to 3 minutes. So the installation is done, as you can see over here. So now you can just type in Jupyter space notebook. Jupyter space notebook, and you will see that it would start the notebook, and this would open a Chrome tab or like any browser. It would kind of show you just like we have done on Google Colab. So here, instead of running it on cloud, so we have installed Python on our machine, and we did a pip install of this Jupyter thing so that we can access this notebook. So here you will see this desktop, documents, downloads, like all the folders that you have on your particular user. So what I can do is I'll come back to this desktop, and I'm going to create a folder. So I'll just like do a right click, create new folder, and I'll just create a folder called this Jupyter Notebooks. The reason I'm doing is I can keep all the Jupyter Notebooks in one folder instead of like saving it somewhere. I can just like organize this. That's the reason. But it's not like you have to do that. You can just like create it anywhere. So once that's done, I can open this desktop, and you will see this. Sorry. So you will see this Jupyter Notebooks folder that you have. So once you open it, you can just like create a file. So you can do a right click, create a new tab, or you can also go to the file and create like a new notebook and all those things. So right click here, give this new notebook, and this Python 3 is like what we have installed. So you can just like leave it as is and click on select. So here we have Python as our interpreter, and again similar to Colab, you can just like rename this as Python getting started. So basically Google Colab is also based on the Jupyter Notebooks environment. So it's like very similar to this. So yeah, and I can just say print hello world and run this. Again, to run this, you can press this run symbol, or you can just press shift plus enter. That's going to run the cell and move to the next one. So this is completely running on your local. So this is not running on cloud and all those things. So this is running on your local. A few things that might be useful to you. So if you go to this settings, right, on the settings you have auto close brackets. So when you do that, when you open parenthesis, it will automatically add a closing parenthesis as well. If you add quotes, it will automatically add a ending quote as well. So here I'll say, let's say hello Python. You can do stuff like that. Okay, so this is how we can do it. Also, if you want to create a text cell, you can just add a cell over here. So we have added a cell. You can also like move it above. Let's say I want to move this here. Okay, so I've moved it. Now we can just say okay, I think we have a shortcut. You can just press em. So that would make this as a text cell, which is basically like a shortcut for markups and so on, markup, markdown. So I'm not sure the exact one, but yeah. So if you want to convert this back to a code cell, so on the code cell you will see this square brackets colon, but for text cell you won't see this. So here if I paste or type something like this as Python, so that would act as like the text cell that we have seen over here. You also have like an option to convert a particular cell into a text cell as well, so it should be like somewhere here, but that's okay. So let's say that you again click this over here. So this cell is selected. You want to convert this to a text cell, right? So you just press M and it has been converted to a text cell. And then you can just, if you want to convert it back to a Python code cell, you can just press Y. So Y would convert it to a code cell. Yeah, here it is. So if you select this and go to this drop down, so there you can select whether you want it as a like a raw cell or a markdown or a code cell. You can just like select it over here, or easier way would be just to press M for text cell or Y for code cell and so on. So this you can do as well. So these are like the few things. So this would be saved in your local in the desktop directory that we have created. So this would be saved as a .ipynb file that you can use. So if you want to delete a cell, you can just like select this. You can just like press this delete symbol, or again select this somewhere here and press D. So double D would delete it. So I'm selecting here and pressing D 2 times, so that would delete it. So this is how you can delete it, or press it over here. So this is how you can write your Python codes in a Jupyter notebook environment. So I hope this is useful to you. So in the next section of the video, let's understand about PyCharm installation. Alright, now let's talk about PyCharm. PyCharm is a powerful, full-featured IDE, short for Integrated Development Environment. Think of it like a smart workspace built specifically for coding in Python. While tools like Google Colab and Jupyter are great for beginners and data-focused workflows, PyCharm gives you a more professional setup, which is exactly why it's widely used in organizations. In fact, if you ever build real world applications, work in teams, or need deeper debugging tools, right, chances are you will end up using something like PyCharm or VS Code, the Visual Studio Code. As you grow beyond basics, PyCharm will also grow with you. You can run large apps, connect to Git, use AI coding tools, and organize massive code bases with ease. So that's why many developers use it daily in their jobs. So if you want a more structured, professional setup, especially for long-term development, PyCharm is the way to go. It might feel a bit heavier at first compared to Colab or Jupyter, but once you get used to it, you will never look back. So let's set it up and explore how it works. So I'll show you the installation in Windows machine. So I have my browser over here. So the first step is installing Python. So we have already done that. So you can confirm your installation by opening your PowerShell and then running Python version, which we already did. So we have like Python 3.1, 3.5 as the version. So once that's done, you need to just go ahead and search install PyCharm on Google. So you will see this JetBrains site. So JetBrains is the organization that kind of like develops this PyCharm application. So you have this option, but you also have this download PyCharm site. So you can directly go to that. So download PyCharm, and depending upon your OS, you will see like the downloader specific for that OS. So here I have this window. So you can go ahead and download this file. So this would be, yeah, so the download has started. So I'm going to cancel it because I've already downloaded it. So the size is about 835 MB. So let me just like close this as I already have it in my downloads. So I'll open my downloads and open PyCharm. So the installation is like pretty simple. It's like not complex at all. So let's see how it goes. So click on next on the welcome page. So this is the destination folder. You can just like leave it as it. So it says that it needs a space of 3 GB. And so if you want to create a desktop shortcut, click this add bin folder to the path. You can do that. Add open folder as project. This not necessary. So create associations, like if you want the .py Python files to open with PyCharm, you can click that and click on next. So all these things, like you can just leave it as it is. Like the start menu thing is what it is. So you can just like do it as it is. So I'll pause the video and I'll continue like once the installation is done over here. So the installation is completed. Took like 5 minutes for me. So you have to reboot now, but I'll choose this. I want to manually reboot later. So I'll click on this finish. So PyCharm is installed now. So go ahead and open this. So this is the starting screen. Okay. So here we have projects, right? So when you first open this, you can just use this new project option. So click this new project. Okay, and here we have to give the location. So by default you would have this Python PyCharm projects folder created. You can do that, or you can just like go to this browse option. You can just like create a folder in your different disk, and you can do that. So for now I'll just like stay here, and I'll use this Python project. So this is my project directory. Within that I would create like all the files, and there I would like create a virtual environment and so on. So I have this Python project, and the best way to work with project is that you can use a Python virtual environment. So it's like when you're working in multiple projects, each of these projects should have a virtual environment. It's like we have libraries in PyCharm and in Python, and for different projects we may use like different library versions. So you would isolate the libraries and the virtual environment for that project. So it's like each of your project would have a separate virtual environment. So that's the idea. So here you can either use this project VNV, or you can use a conda environment, or you can give this custom environment. So you can use like what you have to use. So we can use this virtual env. So base Python, this is what is installed in our machine, the one that we have installed now, the 3.1 3.5 version. So if you want a different version, you can also click the desired one, and that will download, and you can just like use it with PyCharm. So all you have to do is create a project in your desired folder, choose custom environment, just leave these as it is. So generate new and other stuff, and click on create. So this would create that project in your PyCharm. So this is named as Python project by default, but you can give any name. So this is that directory that we have. So I'll maximize this. So now I can right click here and create a file. So let me create a file and call this as getting underscore started. Okay, so this is just like some welcome screen, so we can close this. So you see this .venv, right? So when you create a new project and add a virtual environment, so this would create a .venv file where all your libraries and everything are installed over here. So we have this getting started thing. So here I can just say print hello world and run this. So that would run, and you will see the output over here. So we have this hello world. Okay, so this is how you can get started with PyCharm and like install it and use it. So all you have to do is make sure that you have installed Python on your machine, and then you can create a project with a virtual environment, and you can create your files and you can work on it. So all the files that you work on in this project will be stored here. So this is how you have to use it. So you can just like explore this settings in order to increase the sizes, fonts and everything. So yeah, so that's about using PyCharm. So try these things as well. So far we have discussed about Google Collaboratory, Jupyter Notebook, and your PyCharm. So there is like another useful one which is related to Jupyter Notebook. So it's called as Jupyter Lab. So for this, let's say all you have to do is like open your PowerShell and run pip install Jupyter Lab. Again, it's basically Jupyter Notebook of what we have installed, but it's better for organizing and using the terminal and so on. So run this pip install Jupyter Lab, and once that's installed, you can run Jupyter Lab. Okay, so it should be Jupyter space lab. Okay, so this would open again, just like Jupyter Notebook, it would open this. So now you have like all the folders that you're seeing. So let's say that I'm opening that Jupyter Notebooks folder that I've created. So here I can again right click and create the new notebooks, or I can click this. So that would create a notebook in this directory and so on. The advantage of using Jupyter Lab is like you see like all the files and so on, so and then like you have the plugins details and all those aspects. So you have the directory structure here. So if you want to access the terminal, you can just like open a new tab, and you can access the terminal, and you can run terminal commands and so on. So it is also like pretty much useful for you. And this is what we would predominantly use, Google Colab and Jupyter Lab, for our development in this course. But again, if required, if we are working on projects, we will use PyCharm as well. So here again, the concept of cells and everything is same. It's just kind of like a different UI with some other utilities compared to Jupyter Notebook. So that is about it. So here again, I can just like run something like print hello world and press shift plus enter. So that's going to run and give you the output over here. So these are the 4 things that we have discussed. So one is your Google Collaboratory, which runs completely on cloud, and then we have Jupyter Notebook, which is much similar to that, but it runs on your local machine. And then we have this Jupyter Lab. Again, Jupyter Notebook and Jupyter Lab are like pretty similar. It just gives you some additional utilities. And finally, we have also discussed about like a full-fledged IDE, that is PyCharm. So VS Code is also used just like PyCharm. So again, if you are working with some other programming languages, if you have used VS Code already for development, you can also like use that as well. So it is also like pretty similar to how you would use PyCharm. Okay, so this is it about this first section of the Python crash course that we are seeing. So far we have discussed what is meant by Python, the uses, applications, and so on, and now we have discussed like how to set it up. So next section onwards, we are just going to dive directly into learning the concepts and writing Python codes and all that. Okay. In the second section of our Python crash course, we are going to discuss about Python basics. Here we will be covering the topics such as variables, data types, input, and operators. Here you will learn the absolute essentials: how to store data, take user input, and do simple operations. Let's break it down step by step. So for doing the hands-on part, we will be using Google Collaboratory. So I have my Google Chrome open here, and I've searched for Google Colab in Google search bar. So we have colab.research.google.com, as we have seen in the previous section. So I'll go to this site. So if I'm logged in, I would see an option to create a new notebook. So I'll go ahead and create a new notebook over here. So currently it is loading. So now once it is ready, we can give a name to this, and then we can connect to a session and we can just get started with this. So I'll rename this to Python underscore basics. And here I can click on this connect. So this is going to connect to a runtime. So once that is connected, you can write and run your Python codes over here in the code cells and in the text cells that you have. So the first part that we will discuss here will be variables. So before writing any code, I can create a text cell to mention that. So I'll say variables. So I can make this bold as well by selecting this entire text. Okay, so first let's understand what is meant by this variables. A variable is like a labeled box where you store information or you store data. In Python, you don't need to declare the type, just assign a value and Python figures it out, like what type of variable it is. Whereas in the case of other programming language, you would mention that this variable is an integer, this variable is a string, and so on. But in Python, we don't have to do that. So let's understand how we can define this variable. So here I'll write a comment just to give a description of what that code is. So I'll say variables are used to store data. So this is what we call as a comment. When we start with hash symbol, Python is going to understand that it's a comment and it's not a code. And in the next line, I'm going to create a variable called as name. So I'll say name is equal to Alice, and then age is equal to 25, and then I can say height is equal to 5.7, and let's say is student is equal to true. Okay, now we can output this variables. So I'll write another comment and say output the variables. So here we can say print within quotes name. We can put a comma and say name. So similarly, I'll just copy this. So print statement is just to display the text or any content. So we use this print, which is mainly like the output operation that we have in Python. So here I'll say age of the person. So here age would be stored in the variable called as age. And next one is we have height, right? So here I'll call this as height, and this should be replaced with this height. And finally we have a student. So I'll say is a student, and this should be replaced with is underscore student. Okay, so I'll run this. To run this, I can press this run symbol, or I can press shift plus enter. Okay, so these four things are our variables. So name is a variable, age is a variable, height is a variable, and is student is a variable. So here name is a string. Strings are kind of like text. and all the string data should always be enclosed within quotes, whereas if you see the numbers and all that, we don't have any quotes, double quotes or single quotes, whereas string should be enclosed in quotes. So we have name as Alice, and then we have age as 25, height as 5.7, right? So age is an integer, so name is a string, age is an integer value, height is a floating point value which is a decimal value, and yes, student is a boolean value. So booleans are nothing but true or false, just you have like either true as value or false as value. Even boolean should not be enclosed within quotes. When you enclose in quotes, it would become a string value. Okay, so these are the four variables that we have, and if you have seen, we have understood that you don't need to declare like what type of variable it is. You don't need to declare that name should be a string, age should be integer, and so on. You just assign the values to it and Python will automatically figure it out. Okay, so this is about variables. And the next part that we are going to discuss about is data types. So what are all the different data types that we have in Python? So I can create another text cell and make this one bold. Okay, so every value in Python has a data type. So let's see what they are and how to check them. So here I'll say x is equal to hello, and y is equal to 10. Next, let's say z is equal to 5.5, and a is equal to false. Okay, so now I can check this data type by saying print type. So type is going to help you understand like the data type of this. I'll say print type of x, print type of y, print type of z, then print type of a. So let's run this now. Okay, so here we see that x, right? So type of x, it belongs to the class called a string. Y belongs to the class integer or the type integer. Z belongs to the class float, and a is our boolean value. So hello is a string, 10 is an integer, 5.5 is a float value, and then a false is a boolean. So we have discussed that boolean as true or false, right? So these are the different basic data types that we have in Python. And if you want to check the data type, you can use this type and this parenthesis. So I can just add a comment over here, type, open and close parenthesis. So basically type tells us what kind of data we are working with. This is very useful when debugging or when you're like initially learning as well. So this is about like data types and how you can check them. So the next thing that we can discuss is how to get a input from the user. So remember, input always returns a string even if it's a number. Let's try to understand this. I'll create a text cell and call this as taking input. So this is how you would like take a input from a user. So I'll say name is equal to, so we should use the inbuilt function or the keyword in Python which is input. So I can say input of, so use this double quotes string. So what is your name? And then I'll say age is equal to input of what is your age or something. Okay, let's add a question mark over here. So when we run this, the user should give some value to this for first like the age, and the next one is first is the name and the other one is for age, right? And then I can say print hello comma name, and then I can put another plus sign. So this is called a string concatenation. So we will come to that later. Let's see how we can just print this hello with the name. You are let's say age years old. Okay, so let's run this and see. So when I run this, it asks the user to enter a value. So that's why this input keyword is used. So I can say my name is Sid, and let's say I'm giving my age as 26. So when I run this, this print statement is going to work. So it basically, name is a variable, right, as we have discussed earlier. So this variable will be replaced by the value that the user is giving. So once they give the input, so it would kind of like add this in this print statement. So now it says, hello Sid, you are 26 years old. So this is how we can get a user input, and you can print it. Now, as I said earlier when we started with this taking input, that input values, this input always returns the values as a string. So even this age we have given the number as 26, Python would always consider as a string. So string in the sense, it won't take this value as 26 as we have earlier seen for this y and all that. So rather this would be taken as 26 within double quotes. Now it would become a string. So now let's convert the input to numbers if needed, like a age or height, which should be a number, right, and not a string value. Let's see how we can do that. So this is about convert input to int and float. So here I'm going to say age is equal to, I can wrap this entire thing in this keyword called as int, which represents integer. So I can say input, enter your age. Okay, and then we can say height, where we can take like a floating point value. So here I can say float input, and within that we can say enter your height in feet. So this entire thing should be enclosed within double quotes. Okay, so once they give their values, we are going to again do the same thing, print it. So print age and height. So print it, but also we are going to check the type as well. So earlier it would have been string, but now I'm going to print this type of age and then type of height as well. Okay, so now let's run this. So enter your age. So let's say that I'm saying my age is 26 and my height is, let's say, 5.8. I'll press enter. So now it prints the age and height, but the main thing is now it is not taken the values as a string value, rather 26 has been converted into an integer using this int keyword. That's why you're seeing this integer, which is for this line number 8, and here in the case of height we have converted into a float value, so that's why it says class of float. So this is how you get an input from a user and you convert it into your desired data type, in this case, which is integer and floating point value. So that is the next part that we have discussed. So the next part would be about operators, as we have discussed. So far we have discussed about the variables, like you would store the data in the variables like this, and then about data types, the basic data types that we have in Python, and then we have also discussed about how to take input from the user. Output, you can just like use this print statement to just like print it to the user and all that. And next we are going to discuss about operators in Python. So I'll call this operators in Python. So I'll make this bold. Okay, so let's understand this. So there are like different types of operators that we have in Python, and let's discuss about like the basic ones that we often use. So the first operator that we are going to discuss is arithmetic operators. So I'll create another text cell and I'll call this as arithmetic operators. And here I'm going to have two values. Let's say a is equal to 10, b is equal to 3, and then I'm going to print some operator value. So I'm going to say a plus b is equal to a plus b. Okay, so this is like a simple addition. Okay, so this is just a printing string, so this is not important what you have within that, whereas this is what is like important for us. This plus is like one of the arithmetic operators, which is the addition operator. So what happens is when you have this a plus b, it's going to give that value. Maybe I can just remove this part so that it's not confusing, and I can just include a plus b. Okay, so let me put this as a plus b. So here we have not used string, that means we have not used code, so it now becomes your variable. So a is a variable that has a value of 10, which is an integer, and b has another integer value, which is 3. So we have used this plus symbol, which is the addition operator. So when I run this, it says 13, so it adds these two things and gives you that value. And then we have the subtraction operator, so I can say print a minus b, and I'll run this. So this gives the difference as 7. Okay, and then we also have multiplication operator, which is you have to use this asterisk symbol, and then you have to run this. So it multiplies this 10 with 3 and it gives you the value as 30. And then I can use the division operator, so I'll say a divided by b, and when you do this, so you would get 10 by 3, which is 3.3 as a value, and the last value is kind of like rounded up and all that. And next I have a percentage of b, which gives you the reminder when you divide it. Like earlier you would get a quotient when you use this forward slash a by b, and when you use this percentage, it's going to give the reminder when you divide 10 by 3. So the reminder in this case would be 1. So that's why you use this percentage symbol as another operator. And then you would use a asterisk, like you can use asterisk 2 times and say b, and this is for exponent, so it's like 10 power 3, so 10 to the power 3 would be 1000. So these are all the different basic operators that we have in Python. So first we have addition operator, then we have subtraction operator, we have multiplication operators, and then you have this forward slash for division, and then the percentage symbol, which gives you the quotient of the when you divide the two numbers, and then we have exponent as like the other operator. So these are like the basic arithmetic operators that we have in Python. So the next basic operators that we are going to understand is the comparison operators. So here I'll create a text cell and call this as second one, comparison operators. So here similarly I'm going to take two values. Let's say x is equal to 5 and y is equal to 10. Okay, so we are going to work with these two variable values, which are integers, and I'm going to say print x is equal to y. So when I run this, this is like a equal to, just like one of the comparison operators. So this checks whether x is equal to 5. So when you kind of like put double equal to, it's kind of checking. You shouldn't use like single equal to. When you use single equal to, it's like assigning the values, just like how you would assign a value to a variable. So if you want to check whether two variables x and y are actually equal, exactly equal, you have to use this double equal to sign. So it says false, that means like these are like different numbers. But let's say I'm changing this value to 10, so both these are 10, so this x equal to y would give you a true value. So the output of these comparison operators will always be a Boolean value, either true or false. Okay, so I'll change this number again to 5, and now this would give you a false. So this is like checking whether like two values are equal. So similarly you have print x not equal to y. So equal to, when you use double equal to sign, that means like it's checking whether those are like the same values, but exclamatory mark and equal to sign represents not equal to. So this symbol that we have, right, the combination of exclamatory and mark and equal to represents not equal to sign. So when you run this, this is going to be true because we know that x and y are not equal, so this condition gets satisfied, and that's why you kind of use is true. And the next one that I'm going to use is check if x is greater than y, and similarly print x is less than y. So you can like do all those comparison, or I can check like print x is less than or equal to y. Similarly I can check if x is greater than or equal to y. Okay, so these are the different comparison operators that we have. So depending upon like the output, it's going to return you true or false. So let's run this. So first x is equal to y, which is not the case, so this returns a false. And then this checks whether x is not equal to y, so that's why it's become true. And then we are checking x is greater than y, so x is not greater than y because it's a smaller number, right? So this would give a false. And here x is less than 5, and so on. So you kind of have equal to, checking not equal to, greater than, less than or equal to, and greater than or equal to. So you can have like all these comparison operators. So this is like the other basic operators that we have. So the next operator that we are going to discuss is the logical operators. Okay, so logical operators. So here logical operators are used to combine conditions, and the main purpose, like this comparison operator, let's if we talk about this comparison operator, right? So these are used in logic and decisions, which we will cover in the next section when we discuss about this if and else statement, which is kind of this conditional logic. It's used to implement that. Like, let's say if x is less than y, do this step. If x is greater than y, you have to do this step. So you can write those conditions and you can make decisions on your code. So that's why these conditional operators are used with the if and else block, which we will discuss later. So similarly, we have logical operators, and these logical operators are used to combine multiple conditions. Just like we can combine like equal to y, and you can also check whether it is like less than y and so on. So you can just combine these conditions and also like work on it. So let's see about that. So here I'll create a variable called as is adult is equal to true, and then I'll create another variable as id is equal to false. So basically an adult, but that person doesn't have an id. So these are the two things that we have. So here I can say print so let's say is adult and as id. Okay, so let's run this. So it says false because when you use a AND operator, both the conditions should be true, then it would return a true. So if I change this as id to true, right, then it's going to return me a true. So this is about AND operator. So it checks for like the two conditions. So instead of this is adult and as id, you can also have something like x is less than y, but also make sure that x is not equal to y. So similarly, you can combine multiple conditions as well. And when you use AND, both should be true, then it would return a true. So I'll revert this back to false, and we know that as one of those is false, it's going to return a false. Okay, and similarly, let's check if is adult or as id. So we know, right? So the or operators, the logical operators that probably we have studied on schools and colleges and all those things. So and for and you should have like all the values as true or one, whereas or it's like one of those values has to be true. Or you can also think about this as like ones and zeros. Let's say trues are ones and false are zeros. So it's like or would give you a true if one of those values is true. So in this case, this adult is true, so this is going to return a true value as well. But when both are false, and will also give you false, or will also give you false. So that's about or. So and the third logical operator that we have is print not of is adult. So this is just going to revert like whatever boolean value that you have over here. So I'm reverting this is adult. So is adult is true. So that just like gets inverted to false. So basically and or and not lets you chain and flip logic, like very handy in decision making. It's like pretty simple, as we have like probably like studied this earlier. For and like both condition has to be true, for or one of the condition has to be true, and not is just like reversing this. So let's quickly recap like whatever we have learned so far. So first we have discussed about variables, and we know that variables are used to store values and data. And we have discussed about the basic data types that we have in Python, such as integers, floating point values, string, and boolean. And then we have discussed about input statement. So input gets data from the user, and you can print it or do operations on this. And then we have discussed about like three main operators, such as arithmetic operators, comparison operators, and logical operators. So these basics are used in every Python program that we write, and now you know how to use them. Next up, in the next section, we will learn how to make decisions in the code using if, else, and else statements, and for that we'll be using whatever we have learned so far. Okay, yeah. The third section that we are going to discuss is control flows, where we will learn how to use if, and else. So far you have learned how to store values, use data types, and perform operations. Now let's make our code think and decide with if, and else statements. So in real life, we make decisions all the time. If I'm hungry, I'll eat. If it's raining, I'll carry an umbrella. Python does the same thing using conditional logic and control flows. So let's try to understand this with some hands-on code. So I'm going to do this coding part in Google Collaboratory. So I've connected my system in a new Python notebook environment in Google Collaboratory, and let's start. So for the first step, let's start with a basic if statement. So I'll say basic if statement. Okay, so here I'll write a code. Okay, so let's start simple. Check if a person is an adult based on age. So here age is equal to int of input, enter your age. So this prompts the user to enter a number because we are using the input keyword that we have discussed earlier. And then this int would convert this value because the value would be taken as a string, right? So this is converted into an integer. And if age greater than is equal to 18, so this checks if the condition is true. That means if the person's age that they have entered, whether this is like equal to 18 or it is greater to 18. If this condition is satisfied, if this is true, then the indented part, so you see this indentation here, right? So this indented part would run, which as the print statement saying that you are an adult. So notice this colon. So when you create this colon, automatically the other subsequent lines would kind of be present within an indentation. So this this kind of creates a block of code. So this block is for the if statement. Okay, so I'll maybe repeat this to get more clarity. So the input statement would get the value from the user. The int keyword would convert that input, which is a string value, into an integer value. And if age is greater than or equal to 18, would check if the condition is true. If true, then this indented part below the print statement, so this would run. If not, Python does nothing, just like it would skip this because this condition is not satisfied. Only when the condition is true does the message appear. So I'll run this. So if I give the age value as 20, it's greater than 18, so it's going to print it. So it says you are an adult. So if I run this code again, if I give a value like 15 which is less than 18, it's going to say it's not going to print that, it's going to skip that because this condition is not satisfied. Okay, so this is how you can use a basic if statement that would perform an operation in that block if only if the condition is satisfied. Okay, so the next thing that we are going to discuss is about if and else statement. Let me make this bold. So now let's add a backup plan for this thing that we have created. So if the person is not 18 or older, show a different message. So we would still keep this, but add a else statement like this. Okay, so similarly I'm getting the age from the user and then converting it to an integer. So if that person's age is greater than or equal to 18, so we can say you can vote. The otherwise, like, we have a fallback in else saying that sorry, you're too young to vote. So if this condition is not satisfied, right, so this else is going to run. So I'll run this. So if I give the value as, let's say 20, it says you can vote. Whereas if I give a value as 16, which is less than 18, it's going to say sorry, you're too young to vote. We also have the condition of equal to 18, right? So we can also try putting 18. So even in this case the condition is satisfied because we are checking whether it is greater than or equal to 18. So it says you can vote. Okay, so if age is greater than or equal to 18, the first message appears. So this is my first message. Otherwise the else block runs. So remember, if this if condition fails, else is the fallback. When nothing else matches, this final else statement would run. So that is like the idea. You can think about else as like the fallback or the condition that would run if the else if the if condition is not satisfied. Okay, so this is about using if and else in your code, and only one of this is going to run always. It's like there's no chance that both if and else would run because the condition can be either satisfied, like only in one of the cases. So that's about it. And in the third part we have if, else if, and else statement. So here else if basically it's a short for else if. Okay, so let's say you're grading a student. In that case we need to check for multiple score ranges. So we can't rely only on if and else, so there can be like multiple conditions that we have to check. So in that cases we can go with this else if block that lets you check for like more than two conditions in the just like apart from this if and else we can like check more conditions. So if you see this, we have one if block. So if the student gets a score of greater than 90, it's going to say grade A. But we also have else if this mark is greater than or equal to 75, B. If it's greater than or equal to 60, it's C. And then we finally have a fallback, which is going to, if none of these conditions are satisfied, it's going to say D or below, keep learning. So this is what it does. Okay, so what happens is Python checks each if and else if from top to bottom. So like in this order, it's going to check for all these conditions that we have given here. As soon as it finds a match, it runs the block and stops there itself. Like if none matches, then else would run. So if one particular condition, let's say this condition is matched, this is not going to run and the else is not going to run. So it stops the moment a particular condition has been satisfied in a particular block. So you can have one if, multiple else if, no matter how many, but you can have multiple else if and one final else. So it's like if, any number of else if, and finally one else. So this is like the syntax that we have. So here I'll run this and let's say give a value of 95. So when I give 95, so the first condition itself is satisfied. So this is going to be printed and the other ones will be skipped. So here I'll press enter and it says grade A. So now I'll run this again and I'll give the value. So this should be less than or 60, right? So for else to run, I have to give like a value that is less than 60. So I'll give 40. So the final one runs, which is grade D or below, because all these conditions would be checked and no condition would be satisfied. So it's not greater than or equal to 90, 40 is not greater than or equal to 75, similar to 60. So only like the final condition is going to run. If I give a value like, let's say 78, so this grade B is what we are going to get, because it's this condition is satisfied, this is failed, this is satisfied, so it would stop thereafter. So I'll give this value as, let's say 78, and we would get the grade as B. So this is how we can have multiple conditions and we can check for it. So the next thing that we are going to work on is nested if statement. Okay, so I'll make this bold. So sometimes you need to check one condition inside another. This is what we call as nesting. So I'll paste this code. Okay, so here first we check if the person's age is greater than 18. Okay, so in this part we would check that. If this is true, we go inside another if and else block, right? So if true, we go inside another if block to check if the person has an ID or not. Okay, if either false, if like both of these two things false, right, and then like we would have this print statement finally. Okay, so nested logic is useful when decisions depend on previous checks. So it's like first we have to check whether the person is over the age of 18, and then we have to check if they have a valid ID with them. Okay, so if the person is over 18 but they don't have an ID, then we print this message. Okay, you need to show ID. If the person is 18 and they also have ID, then this yes condition is going to be satisfied, right? So this entry allowed is going to run. If they don't have this ID, sorry, if they are not over 18 at all, then we say that you are not allowed, must be 18 or older. Okay, let's run this. So let's say first a person goes with age of 25 and they say that they have an ID, so they're going to give the value as yes. So we check if this yes is present, so it would say entry allowed. If I run this and I say the person is over 18 but they don't have an ID, right? So this message, you need to show ID, would be printed. You need to show ID. If the person is not over 18 at all, let's say the person is 16, in that case it's going to say, do you have an ID? It says, let's say it should not go there at all. Let me see. Okay, so if I say no, you're not allowed, must be older, or sorry, yeah, you're not allowed, must be 18 or older. So this is how you can like nest multiple conditions within that. Okay, so this is about it, right? Right. So here, as you can see, right, so we gave like two input. Maybe I'll run this again so that we can understand this better. So I'm giving the value as 16 and it asks if if I have an ID. So I'll say no. Now it says you're not allowed because you must be 18 or older. This would be the same case even if I have an ID but I'm underage, because that's kind of not a valid scenario, right? It's like they don't have like a proper legal ID. So let's say that the condition is only persons with age of over 18 kind of gets that ID. So I'll say 16. Even if I put yes, what happens is this if condition itself blocked, so it won't go to this if else block at all, but it just like gets this two variable values. So I'm 16 but I have an ID, but it says you're not allowed, must be 18 or older. So if this condition is not satisfied, this entire block is skipped, just like we have in this case, and it directly goes to this else statement and it would print this. Okay, so that is the concept behind it. And next we have the option to combine condition with and, or you can use the or operator that we have seen in the previous section. So I'll call this as the fifth scenario that we are working on, which is combining conditions with and or. Okay, so this is also something that we have discussed in the previous section when we were discussing about operators. So instead of nesting, you can also combine conditions on one line using and, or, and not, just like this one, but you don't have to nest that. So that's the purpose of this. Let's say that we have this code. So instead of checking it in multiple places, it would check if the person is over 18 and they have a ticket. If that is, then it says like welcome to the concert. If not, it would say sorry, you must be 18 and have a ticket. So it's just kind of like the previous case that we have discussed, but it is like more simple because now we only have like one if else block, and we have just like added the conditions in that instead of nesting it. Okay, so I'll run this. So if I say I'm 20 years of age and I also have a ticket, yes, then it says welcome to the concert. Whereas if I'm 20 years of age but I don't have a ticket, then I'm not allowed. So it says sorry, you must be plus 18 and also have a ticket. Whereas if I say I'm 16 but I have a ticket, then I'm not allowed. Sorry, you must be 18 and have a ticket. And if I'm 16 and I like don't have the ticket as well, like, then both conditions are like not satisfied. So it automatically goes to the else statement. So just like the nested statements, when you want to um, like check multiple conditions, you kind of use this combination of multiple conditions using the operators that we have seen, the and. You can also like use this or. When you use this or instead of this and, right, then one of those is going to run. So you can just like try it with and as well, like either one condition should get satisfied. In that case, if they are 18 they are allowed, or if they have the ticket they are allowed. It's kind of like that. Okay, so those are the different types of ways you can use a if, else, and else statement. So let's just do a quick session recap of what we have done so far. So we have used if to check a basic condition first, right? So in this case, and then we have used else to handle the opposite case, like having a fallback, and then we have used else if in order to check for multiple conditions, and then we have used nested block nested if statement for deeper checks, so for having like multiple checks within like a particular if block. And finally we have combined condition using and like again you can use or and not as well. So now your Python programs can make decisions just like real world logic. So this is all about the control flows, where we have discussed about if, else if, and else statement. And in the next section we will learn about loops so that your code can repeat actions automatically. The fourth section of our Python crash course is about loops. Imagine you want to print a message 10 times. You could write the same line 10 times, but that's not smart. Instead, we use loops. Loops let your code repeat automatically until a condition is met. Let's explore the two types of loops in Python, for loop and while loop. So I'll open my Google Collaboratory. So here I've created a notebook called as loops.ipynb, and I'll click on this connect so that I can get connected to a runtime. Okay, so let's understand about the for loops and while loops. So I'll create a text cell and I'll call this for loop. So the main difference in each of these is right, if you think about the for loop, for loops are used when you know how many times you want to repeat something. Let's consider this example. So here I write a code like this. So here I'm saying that print hello 5 times. So when I know that I want to print something or do something a particular number of times, so in this case which is 5, right? So when I know that number of times I need to repeat an action, I can go with for loop. But when that number is not certain for me, so when there is an uncertainty on like how many times a particular task has to run, in that case we can use while loop. So that is the main difference. So in this case, let's say that we want to run or basically print hello 5 times, then we can use a for loop. And before that we need to understand this range keyword. Okay, so I'll also create another code and print something like range of 5. So when you run range of 5, or let me print this, so it's going to give you the values between 0 and 5. So 0 would be included but 5 won't be included. So it's like range of 0 and 5, right? So basically it takes the value from 0, 1, 2, 3, and 4. If I put the asterisk symbol, so it's going to give you all the values. So when you use the symbol, right, it's going to print all the values within this. So it says 0, 1, 2, 3, and 4. So range of 5 contains these 5 values. As it starts with 0, it doesn't include this number 5. So if I have this print asterisk of range of 10, right, so that would include from 0, 1, 2, 3 all the way up to 9. So the number that's present over here is not included. You can also include the first number. If I want like 1 to 10, I would give this as 1 and 11. So the first number that you give within this range is included, the second number is not included. So when I run this, I get the value from 1, 2, 3, 4, and 5. As you can see, 11 is not included. So always the first number is included, whereas the second number is not included. So this is about this range, and this range is used here. So if you see this one, right, so the range of 5 generates number from 0 to 4, as you can see over here. So it's going to generate number from 0 to 4, not including 5. So that's very important to remember. And I takes the values one by one. So I takes all these values one after the other. So when the for loop runs for the first time, I takes the value 0 because that's what's the first number present in range. And when the loop runs the second time, I takes the value 1. Then it takes the value 2, 3, 4, and so on. Okay, each time it returns this print of hello. So this loop runs 5 times. I is the loop variable and it changes each time, and this is the syntax. So you have to say for, and you have to mention a variable here. So for variable in range of 5, print this particular thing. So when I run this, this is going to print like this many number of times. In order to understand this or remember this simply, if you want to perform a particular action 5 times, put range of 5. If you want a particular option or an action to run 10 times, put 10 here. So you don't have to worry about that 0 and ending value 5 and so on. It's better to remember this, but for easier purpose, if you have like, let's say it needs to run n number of time, put that 10 here. If you want this to run 10 times, you put 10 here. So you would see like 10 allow statements print over here. So here I'll give this as 5. Okay, so this is the syntax for this. So the next case, let's say that I don't want to print hello, but I want to print numbers from 1 to 10. One option is saying print 1 and in the next line print 2 and so on. So rather I can use this. So as we have seen earlier, right, so range of 1, 11 would have the values from 1 to 10. So the first number is included and 11 is not included. So it's between like 1 and 10. So when I use this for number, so this, it's not mandatory that you have to use I. So you can use any variable. This is a variable, so you can use any name. But this in is a Python keyword, so you definitely have to use this. So for number in range of 1 to 11, print number. So this is going to print you the numbers from 1 to 10. So when the for loop runs for the first time, num takes the value 1. So we are printing that num, which is 1. Second time it would take the value as 2, and then we are printing this 2 and so on. So this is how you can print the numbers from 1 to 10. Okay. So the next step, we can also do some operations on this iterable object. So here what I'm going to do is print squares of numbers from 1 to 5. So similarly, when I say 1 to 6, it's going to take the values like 1, 2, 3, 4, and 5. And in each case, I'm going to print the square of this number. So when I run this, it's going to say square of 1 is 1, square of 2 is 4, 3, and so on. So here I'm printing x, but the actual value is x of x. I'm taking like a square. So this is how not only you iterate over a number, but also like do a square, or you can also like do operations on this, like different operations on this. So this is how you can use a for loop. And as you can see, in all these cases, we know how many times we want this particular action to run. So in this case, we wanted it to run 5 times, and in this case, we wanted it to run from 1 to 10 for 10 times and so on. So this is about for loop. But if you consider while loop, right? So the next section is about while loops. So let me just type it here. Okay. So while loops runs as long as a particular condition is true. You can use them when you don't know in advance how many times it should run. Let's consider an example. So this is the syntax for while loop. So you would have a while, and then you would have a condition. Here we have a condition to check whether the count value is less than or equal to 5. So here we initiate the count variable with value 1, and at each operation, or basically when while loop runs once, it should increase the count value by 1. So same as count is equal to count of plus 1. This is just like another way of representing this count plus 1. Count plus 1 is just like saying count is equal to count plus 1. That means at each step, increment this value by 1. So start with count is equal to 1. This keeps running until the count is less than or equal to 5. Okay. So basically when count value is less than or equal to 5, this is going to come as true. But once the count value is greater than 5, that is when it reaches 6, this while loop is going to stop because the condition is not satisfied. Okay, so to just like sum up everything, you start with count of 1, keeps running while count is less than or equal to 5. This is true. After each loop, it increases the count by 1. Okay, so loop stops when this condition becomes false. When it becomes false, when the count value is like 0. So let's run this. So we have count is 1, 2, 3, 4, and 5. So if you say that 10, you can also like, yeah, if it's 10, right, it means like it would run when the value is like it would start from 1 and it would continue till the value is 10. But the moment the final 10th thing run, the count value would become 11 and it's going to stop this condition. So this condition would give you a false, then like it would stop there. So this is how you can write a while loop when you don't know like how many times it should run. Rather, in the previous case we have said that it should run 5 times or it should run 10 times, whereas here we are not saying that it should run 5 times or 10 times. Rather, we are saying that run until this condition is true. Okay, so that's the main difference, not the exact number but setting up a condition for this. But the other main aspect of this to consider is, if you forget to update this condition, right, what happens when I comment this out? That means your count will always be 1 and your count will always be less than 5. So this leads to the problem of an infinite loop, which is a big issue. So when you run an infinite loop in Colab, right, so that means the process doesn't stop and it fills out the RAM and all that. So basically your system crashes. So if you forget to update the condition, the loop will run forever, and this leads to a problem called as infinite loop. So I'll give you the code, but please don't run this, or even if you are running this, run it on Google Colab, not in your system, because it would like crash it, because it's like a never ending loop and it's going to consume like the resources and so on. So I've commented this code out, but yeah, it's just to say that don't run this. Okay, so this is commented out for safety. Avoid infinite loops unless like you handle breaking them properly. So there should always be a condition to break this. It's when we are developing a program, so we have to make sure that we not accidentally we are like creating a infinite loop. In this case, if you see while true, print this is an infinite loop. So when I uncomment this part and run this, right, the condition is always going to be true. We are not updating this condition, so it prints this is an infinite loop line again and again. It would never stop, which leads to this infinite loop issue. So that's why I've just given you an example with this commented part, but again, don't try this. Okay, and there are also like other things that we can work with, like when we talk about loop. So this is about loop control. Okay, so here we can discuss about break statement and continue statement. These are the two special cases that we have that basically goes hand in hand when we work with loops. So here I'll use this particular code block. It's basically to learn how to control a loop's flow with like break and continue. So here in this case what we are seeing is I in range 1 to 5. That means 1, 2, 3, 4 and 5. These are the values. But when I is equal to 3, stop that. So it prints 1 and 2 and then I becomes 3 and it stops and exits the loop. So break stops the loop immediately, and this is useful when you found what you need. So let's say that you're like trying to find a number in a list, or like you're trying to find a number in a particular list of numbers, right? Once that number is reached, you don't have to do that again and again. So that's the idea. Let's say that we want to stop this when 3 is reached, but you don't know when that 3 would come, then you would run this. So I'll say this. So it would print 1 and 2. So what happens is when the for loop runs for the first time, it takes the value 1. It checks if I is equal to 3. So I is not equal to 3. So which means like 1 is not equal to 3. So this would break it and we would print this value, right? And in the next case, this takes the value of 2. And again, it checks if the value is 3, it is not. So it would break this. So this process basically goes on, and break statement is used when a particular condition is met. Okay, so that's the purpose. And again, as I said, the purpose is like it's useful when you found what you need, so you don't want to run this again and again. Okay, so that's why break is used. So specifically for breaking a loop, like when a particular point has been reached or the purpose of your code has been reached. And then we have this continue statement, which is also like pretty useful. So you use continue when you want to skip a particular step but not the entire loop. So in this case, if you see, right, once 3 is reached, we are not running it for the other numbers 4 or 5, but let's say you want to do the similar thing, but you don't want to break it when it reaches 3. You simply want to skip 3. In that case, instead of break, you would use continue. So what this would do is this would print 1 and 2. When I is equal to 3 comes, this would skip the lines that's present in the loop after this continue statement. So continue basically like skips whatever comes after that in that for loop. Okay, so that's how this works. So the main difference is that break would immediately stop the loop, whereas continue would skip that particular iteration. In this case, it would just skip printing 3 because that's the condition over here. Okay, so it prints 1, 2, skips 3, and then prints 4 and 5. So continue skips the current loop iteration, then continues with the next. So you use continue when you want to skip a step but not stop the loop. Okay, so these are like other two controls that you can have on your loops. So let's just do a quick recap of what we have seen in terms of this like for loop, while loop, and controlling these loops. So first, like we used for loops when basically we understood that we use for loops when you know how many times we want that to run, and then use while loops when you don't know how many times it needs to run. And then we have this break statement, and break exits the loop early, like when a particular point is reached, whereas continue skips the current step, but it would kind of keep the loop running for the other values and so on. So uh, so loops help you basically write less code and do more. So you don't have to say like have 6 print statement, or in this case if you see, right, you don't have to have like 10 print statements. So that's the main purpose. Loops helps you to write less code and do more with it. They are the key to automation, processing data, and handling like large tasks and all that. Okay, so that is all about loops, and in the next section we will look at Python's built-in data structures such as lists, tuples, set, and dictionary, and how to use them to organize your data efficiently. The fifth section of our Python crash course is about data structures. In the real world, we often deal with collections of things such as a list of names, a set of colors, or a table of employee records. Python gives us powerful ways to store and organize such data using built-in data structures. In this section, we are going to learn about 4 key data structures that we have in Python, such as list, tuple, set, and dictionary. So let's get started with the coding part in Google Colab. So here I've created a notebook called as data structures, list, tuple, set, and dictionaries, and I've connected it to a runtime. So the first topic that we are going to discuss is about list. So here I'll create a tick cell and say that lists are ordered and changeable. So when we say changeable, we kind of call this mutable data types. So I'll make this bold as well. So let's discuss about this. So when you think about list, so they have a characteristic of being ordered and changeable. So a list is like a container that holds multiple values in order. You can add, remove, or change items in it. Okay, so that's about it. So let's see how we can create and access the items present in a list. So here I have created a list called as fruits. Okay, so creating a list of fruits, and here I have 3 strings. I have apple, banana, and mango, and accessing items using index. So the index would start with 0. So the string apple would have the value or the index as 0, and banana would have an index as 1, and mango would have an index of 2. So we have 0, 1, and 2, and as I've mentioned here, the index always starts at 0 in Python, like in this list as well. So it would start at 0. So this is why we call it as ordered. So all these list values can be accessed by using this ordered index. So that's why we call it as ordered. Okay, so here we are creating a list of fruits with apple, banana, and mango, and in the second part we are accessing it by using this index. So when I say fruits of 0, it's going to print this apple. When I say fruits of 1, so you kind of print banana, and you can access it by mentioning this square bracket of 0 and so on. And then you can also change an item. As we have mentioned, it is a mutable data type. That means it is changeable. So once you create a list, you can change this. So in this case, I'm saying fruits of 2 of orange. That means 2 index represents this mango. So this mango would be changed as orange, and then we would print it. Okay, so this is how you can create a list. You can access the values present in a list, and you can change an item that's present in a list. So here first we have created a list, right? So as fruits, you can also like print this fruits. So here I'll print this. So this would first like print the list, the original list, which has apple, banana, and mango. So we can access it using index, as it is a ordered data structure. So I'm accessing it with index of 0, which represents apple, and 1, which represents banana. So we have printed these two things, and then we can change an item as it is a mutable one. So I'm saying fruits of 2. So fruits of 2 represents this mango, and that is replaced by this new string called as orange, and then we are printing this changed fruits, which is this. So lists use square brackets. So when you want to create a list, so you would put the values within a square bracket as it's mentioned. So items are ordered and can be accessed by position, which is nothing but our index, and you can modify items. So these are the three main key factors to understand about list. And the other one is you can have like combination of data types as well. So here it's not like we only can have strings. So all these three values are string, right? So it's not like that. You can also have a floating point value. You can also have a integer value within this as well. Let's say I have creating like a list which also has an integer value, which also has, let's say, a floating point value. It can also have a boolean value as well. So it can have like multiple data types as well. It's not like it should only contain like strings and all that. So that's about it. So for now I'll remove it, but like that's the idea of this. So it can have like support multiple data structures at once. There are also several operations that we can do on list, but again, for this crash course we will just stick to the basic operations, but still you can like focus on more operations that we can do. Or let's say if I'm making a separate crash course for data structures and algorithm, maybe there also we can discuss about it. But for now I'll just like explain about these things. So first we have an append operation. So in order to do this, first you create a list, right? So we have already created a list, and then we have updated the second value to orange. So the final list that you have is apple, banana and orange. So this fruits is getting used in the subsequent cells, so this list. So here we are adding an item to the end. So to do that, you just say fruits, which is the name of the list, dot append grape. So this is going to add a new value to this list called as grape. I can also add a print statement to just like see it at that point. So I can say print fruits, and then I can also remove a value. So in this case I'm removing banana. Okay, so let me print this again as well. So print fruits, print banana, and then you can check the number of elements present in a list by using this length, len. So this is also an inbuilt Python keyword, len, which stands for length. It's going to return like the total number of values present in a list. And the other main aspect of this list is you can also loop through a list. This maybe I can put it in a separate cell so that it's easier to kind of like understand. Okay, so first let's do these three things. One is we are adding a new value to a list, and then we are removing a value from a list, and the third one is check the total number of values present in a list. So let's run this. So first we add this apple, banana and orange. So to this we have added a value called as grape in the first step, and we have printed it, and you can see the print statement here. And in the next step we have removed this banana. So now you can see here we don't have that banana string anymore, and then we are checking the total number. So the total number is 3, which is getting printed here. So for that you can use this length of fruits. So we have used this for I in range of some number, right? So similarly, instead of range, you can also iterate over a list or any like collection of data. So in this, when I say for fruit in fruits, fruit first takes the value as apple, next it would take the value as like orange, then it's grape. So it would iterate over this particular list that we have created, and at each step it would print that fruit. So it basically, the for loop would iterate over the list of fruits that we have over here. So these are like some of the basic operations that you can do, and how you can iterate a simple for loop over a list of data. So lists are great when order matters, when you want to access those with the index and all those things, and also when you need to make changes, right? So it's not like you created but you shouldn't be able to change it later. In that case, like list is useful when you want to change the values that has been created earlier. So that's about creating a list. So the second topic that we are going to discuss here is about tuple. So when you talk about tuple, just like list, right, it is also ordered, but it is unchangeable. Okay, so we have tuple that is ordered and unchangeable. So unchangeable means it's like immutable. I'll make this bold. Okay, so a tuple is just like a list, but as I said, you can't change the values once you have created it. It's kind of like a read only data type. So let's see how it works. So let's say I have colors is equal to red, green and blue, and you can, again, it is an ordered data type, so you can like access it using the index value of 0, 1, 2, 3 and so on. Okay, and the main aspect is you cannot edit the values present in it. Maybe I'll run this separately and show it to you, but first let's run this. So it says red. You can also print the tuple first as well. Okay, so print colors. Okay, so the main difference is you would enclose all the list values within square bracket, but tuples are represented by using this parenthesis. Okay, so you have to do that. So in case you want to check the type, right, so you can just simply run, type. So I'll say print type of fruits. So that's going to say like what that data type is. So it would say it is a list, but when you run this over here, it's going to say it is a tuple. So I'll say print type of color. So when you are not sure what a particular data type is, you can just run type on it. Okay, so we have printed the tuple that we have created, and then you can again access it by using the index. So if you put one over here, it's going to print green and so on. So also you can, like, you cannot change a value that's present in a tuple, as it is like a immutable object. That means you cannot change it. So when you run this, it would say tuple object does not support item assignment. So you cannot like update a value present in it because it is immutable. So in order to avoid this error, I'll just like comment it out. But if you want to test it, like, just try by uncommenting this and run. But if you have done the same thing on list, it would have worked. This is what we have done, right? In the list it worked, but in the tuple gives an error because, again, as I said, tuples are like immutable. So the main takeaway here are like tuples are enclosed in parentheses, and once they created, they cannot be modified, and they are useful when you want to protect data from accidental changes. So these are the main things. So use tuples when the data should stay fixed, like let's say days of the week or coordinates. So these are like fixed values, right? So they shouldn't change. In those examples, you can use tuples. So that's about it. So the next data type that we are going to work on is sets. So I'll say set, and the again difference is this is unordered and unique. So this is about it. Again, you can update, basically you can change it, but the main characteristic are unordered. That means you cannot access the values using any index, so it doesn't support index. And the main thing is you can have unique values, whereas in the case of list, you can have another mango, so it supports duplicate values and so on, but set doesn't do that. So set is always unique. So when you pass a set, or when you convert a list into a set, it removes all the duplicate values. So that's like the main characteristic about it. Okay, so let's understand that. So first we can create a set. We can also like try to give it duplicate values, but it would remove the duplicate values. So here we have three names, set of student names. We have Alice, Bob, Charlie, and again we have Alice. And I run this, you can see Charlie, Alice and Bob. So this is like present like only once, right? So Alice in our code we have repeated it, but as set are unique, so it's going to remove that duplicate value. So that's about it. Again, it is like mutable as well, so you can like remove or add values. Let's say I'm adding and removing values. I'm saying students dot add. So instead of append, just like in list, you have to use add. So in the list we have used append over here, right? So similarly in this case we have to use add. To remove it, you can use that same like remove keyword. So give the name of the set that we have created, which is students, and say add David, remove Bob, and then you can also like print the set 2 times as well. So I'm going to print it. Let's run this and see. So Charlie, David, Alice, and Bob. So David has been added, and we have removed Bob from the set. So this is how we can do this. So similar to iterating within a for loop, even tuple can also be iterated. Similarly, just like list, and similarly list can also be iterated. So I'm saying for student and students, print students. It's going to iterate over Charles, David, and Alice, the final list that we have. So the key takeaway in terms of set are sets use curly braces, as you can see over here. So list use square bracket, tuples use parenthesis, where it is, yeah, parenthesis, and sets use curly braces. So that's the main difference. And so one is like using curly braces, and the other characteristic of sets is that items are unordered. That means no indexing. You cannot access the values with index as you have done with list or a tuple. Okay, and no duplicates are allowed, and it is a very useful mechanic. So let's say you want to remove the duplicate values in a list. What you would do is you would convert that list into a set. That would remove the duplicates, and then you can convert the set back into a list. So you can do all those things as well. And the other is it's great for fast checks and uniqueness. You can quickly check whether there are any duplicates, or like you can remove that and so on. So we can maybe like try this. Let's say I'm creating a list called as my list, and as my list has values like 1 1 2 3 3 4 and 5. Let's say these are the values. So when I print this my list, so it's going to have all these values. But let's say we want to remove the duplicate value. So what I would do is I can just say my list is equal to set of my list, and then again print my list. But this won't be a list anymore, this would be a set. But you can see the duplicate values has been like removed. But let's say you don't want this to be a set object, right? So let's say you still want it to be a list object, so you would include this within a list. So this is how you can do this. You can like convert a list that has duplicate values into a list that doesn't have any duplicate values. So you can just like use this similar thing on tuple as well. Like if you want to convert a list into tuple, just like use that keyword. So you would say that tuple of, let's say, your list that has 1 2 3 4 and 5. So by this you can convert a list into a tuple and so on. You can just like use that keyword. But this is how you can remove duplicate values from a list. Okay, so this is how we can do this. So the next important data structure that we are going to discuss is dictionaries. So dictionary is kind of like very different from the other three data structures that we have seen. So it's slightly like as like more features to it. So it is kind of like a key value pair. Okay, so that's about dictionary, whereas like other things are just like collections of data, whereas in the case of dictionaries you can have keys and pairs. So dictionaries store data as key value pairs, like a real world dictionary would do. Okay, let's understand this. So here I can say I can create a dictionary like this. So person is the dictionary name. I can say name is Alice, age is 25, and is student is true. Again, this is my key. The left hand side strings are my keys, and the right hand things are my values. So name is the key and Alice is the value, age is the key, 25 is the value, and so on. So you have key and a corresponding value pairs. So this keys should not be duplicate, so it doesn't allow like duplicate key values, whereas you can have like Alice 2 times or 3 times. So values are not like they can be like duplicated, but the key values cannot be duplicated. So here I can print it. So print person. So it's basically like the details about a person. In the previous cases you can just like have like list of values and so on, but here you can have, let's say, different characteristics of a person, like different, let's say here we have name, age, student, and so on, right? So it's like very useful over there. So if you want to access like, let's say, the name of the person, in that case you can just say person of name. That's going to print their name. If you want to access their age, you can print the age and so on. So this is how you can access like the individual values and all those things. Dictionaries are also mutable, so you can like change the value as well. So if, let's say, I want to change this value from 25 to 26, I would say person of age is equal to 26. So when I run this and again print the dictionary, again print person. So this is going to give name Alice, age previously it was 25, now we have changed it to 26. So this is how you can do that. So similarly you can add a new key value pair as well. Let's say to this existing dictionary I want to add a new key value pair like city as New York. So when you do that, so we have name Alice, age 26, student, and so on, and then city as New York. So similarly you can change a value like this one, or you can add a new value there as well. So this is about it. So the key characteristics here are dictionaries use keys like name, age, and so on to access it's basically a key value pair, and you can use these keys to access the values. And keys must always be unique, as I said. Like you cannot have multiple keys with the same name. And values can be of any type. It can be a string, it can be an integer, boolean, float, and anything. And you can add, change, or remove key value pairs as well. So that's about it. And then you can also like iterate over dictionary, just like your list and all those things. Okay, so and the other one is like it is also enclosed in curly braces, but the difference is Sid doesn't have that key value pair option. You can just have like individual values, whereas this supports the key value pair with a colon in between to assign like that value to that key. So here we are seeing key comma value in person dot item. So when you say person dot items, so you can iterate multiple variables on a for loop. So when you run this, key would take the keys present in it. So when the for loop runs for the first time, key takes the value name, and value takes the actual value of Alice. When it runs for the second time, key would be age and the value would be 25. Third time is key is a student and true is the value. And then we are printing like key and putting a forward arrow, and then we are printing this value. So we would see something like this. So first time key is name and the value is Alice, second time it's age 26 and so on. So this is how you can use this person dictionary dot items parenthesis to iterate over it using a for loop. So I've just like have this particular kind of a table structure to just like quickly look at things and understand like the different characteristics of these 4 data structures. So I'll paste this in this text cell, so and run this. Okay, so we have list, tuple, set, and dictionary. So list is ordered, tuple is also ordered, set is not ordered. That means we cannot access it by index. Dictionary is also ordered, but not by index but by key, and it is changeable. So list, set, and dictionaries are changeable. That means they are mutable, whereas tuple is it cannot be changed, so it's called as immutable data type. And then allow duplicates. So list allows duplicates, tuple also allows duplicates, whereas set does not allow duplicates. Key, when you think about dictionaries, it allows duplicates on the values but not on the keys. Okay, so that's other thing. And then indexable. So yeah, list is indexable, tuple is indexable. So the set is not ordered, right? So it is not kind of like indexable, whereas dictionary is kind of also ordered but not by index but by key. So these are the key takeaways from this. So this is about like the 4 data structures. So basically each one is suited for different types of tasks. As you code more, you will use like all of these things regularly. So it's like it's not like you always use a list or you always use a tuple and so on. So we would like use all these data structure, convert from one data structure to another depending upon the requirement and so on. So that is about the 4 basic but main data structures that we have in Python. Only difference is that we would use this in a more complex way, but understanding the basics is the key over here. So in the next section, we will dive deep into one of the most powerful tools in Python, that is functions. You will learn how to write reusable blocks of logic and how to keep your code clean and modular. Okay, so let's get to that. The 6th section of this Python course is about functions. Now that you have learned how to store and organize data, let's take your Python skills to the next level with functions. Functions help you write reusable blocks of logic. Instead of repeating code, you define it once and call it anytime you need. They are used everywhere and you will write dozens of them in real world projects. So let's see how we can work with these functions and how we can reuse them. So I'll open my Google Collaboratory and I've created a notebook called as functions.ipynb and I've connected to the runtime. So I'll create a text cell and call this as creating a simple function. So let's start with a simple function first. I'll make this bold. Okay. So when you're working with functions, right, you use the Python keyword def, which stands for define. So we are going to define the function and reuse it later. Okay, so this is how we can do this. So I can say something like def define greet, open and close parenthesis, put a colon, and when you press enter, you would kind of create an indentation, right? And then within this, I'm going to say print hello, welcome to the course. Okay, so we have to run this. So now when I run this, this is not going to print this because we are not printing this, rather we are defining a function. Okay, so we are defining like a simple function. So when you want this function to be executed, you call that function name. So greet, open and close parenthesis, and that would run whatever code you have within that indentation, whatever code you have within that greet. So let's say that I want to reuse this function, I can simply call this greet again. So I can run this again. So that would do this. So this first line, right, def define greet parenthesis thing. So this defines a new function called as greet. The indent block that you see over here, indent is this space. So the indented block is the function body that has the code. So here we have single line of code, but you can have like multiple lines of code, and then you call it multiple times by calling the name of the function. So this is useful when you want to run the same logic repeatedly. So in this case, we just have one line of code, right? But what if there are 100 lines of code, but you have to like reuse this like wherever required, right? Not in one place, but you have to reuse it like in multiple places. In that case, we define it as a function and we can just reuse it by just calling that function. Okay, so that's how we can work with it. And in the next part, let's see how to create functions with parameters. So this is the next kind of variation that we can work with. So let's understand this. So here we didn't pass any parameters to this one, right? So in this case, I can say greet, but this requires a parameter called as name. And in this print statement, this variable is used. So let's say we have a function called as greet, and I'm calling this greet function. I'll call this in a separate cell. Let's see how this works. Okay, so what happens is we call this greet with this function name, and in this name we are passing this person's name, and what happens is it's going to print it, but this name is going to be replaced with this value called as Alice. Okay, so here we have created a function that takes the parameter called as name. You can also say greet name is equal to Bob. This is just saying that I'm passing this name Bob to the parameter called as name. Okay, so this is how you can write a function that accepts parameters. Similarly, we can also create functions that accepts not one but multiple parameters as well. You can create functions that needs like any number of parameters, so we can do that as well. So here I have defined a function called as add, and this add takes two parameters, a and b. So this a and b are added and saved to the variable called as result, and then we are printing this result as this sum is result. So basically when you pass 5 and 3, a would take the value as 5 and b would take the value as 3. So both of these would be added and the value 8 would be stored in this result, which then we are printing. Okay, and then the next is like sending 10 and 20. So first it would print this 8, and this next time the 30 is printed because of this 10 and 20, because of this line. So similarly, you can just pass this 5 and 3. So first value is a, second value is b. So automatically 5 goes to a, 3 goes to b. You can also say a is equal to 10 and b is equal to 20. You can also explicitly mention that as well. So that is like another option. So the next part that we are going to see is returning value from a function. So here I'll say returning value from a function. Okay, so previously what we have done is we have written function that just like simply do the calculation and print it, right? But what if you need that value, you need that some value to be stored somewhere? In that case, we can do something like this. So I can just create a function called a square. So this is going to take a particular value and it's going to square it by using n asterisk n, which is like n into n. So just that. So now it's like if you pass 4, it's like 4 into 4, which is like 4 to the power of 2, right? It's just like basic square thing that we are doing. Okay, so n into n. So in this case, instead of printing this n into n, what we are doing is we are returning it, and this returned value would be saved in the variable called as result. Okay, so here call this square function, pass the value 4. So n would be 4, so it's like 4 asterisk 4, so 4 4s are 16, and that value is not printed but returned to this result. Later we then print this result. Similarly, you can also print this. So when you put a function within a print statement that returns a value, that returned value is printed here. So when you run this, the first print statement is coming from here, which is basically like printing the result value. Here we are like directly passing this function which returns a value to this print statement. So it also like returns that value is 49 and it is printed here. So this is how we kind of return a value from this function. So let's say that first you need to square that number and then you have to divide it by 2. So in that case, instead of adding that by 2 here, you can also get this result and then like do it. It's basically when you want to do something with the output that comes from the function and not just print it. In that case, we can use return statement, and we often use like return statements. And the other type of parameters that we can use is default parameters. I'll use this particular example as well. So here let's say that functions with default parameters. Okay, so here we have created a function called as add, and it requires a and b as the value, and when we pass 5 and 3, it adds the number and it prints it, right? But what if I didn't add the values? So let's say that I'm just like calling the add function, but I'm not passing like 5 or 3 or any numbers. So it's going to say add function missing 2 required positional arguments a and b. So it basically says that add requires a and b as the values, but you have not passed it. Okay, so that's the error. So you always have to pass these parameters. The other way of doing this is when a user doesn't pass a value, you can have a default value that we can pass. So let's say that you can have a is equal to 0 and b is equal to 0. So now when they don't give any values also, you just say that sum is 0 because it takes a default value. So let's say that we have the default value as 3 and 3. So when the user doesn't provide any value, it's going to take this a value as 3, b value as 3 as well. So this is what we call as default parameters. But even in this function, the user they can also send some other different values. When this values are sent by the user, the 3 values are kind of overridden here. So now a is equal to 5 and b is equal to 6 and not 3 comma 3. So this is what we call as passing default parameters. So either you can pass default parameters or you can just like send your own parameters as well. So this is how you can work with that. And the other main important concept that we are going to work or basically understand is about types of variables. So we have 2 types of variables that kind of it's very important when we talk about the functions per se. So those are global variables and local variables. Okay, so let's try to understand this. So I'll say this, can use this one. So let's say I have a function, okay, so that takes a and b as the value. I don't have any default values, let's say, and I'm creating a variable called as output. So basically you pass 2 values here. So I can say that I'll pass this a of 4 comma 4. So a is equal to 4 and b is equal to 4. Run this. So we are printing this output. So we add 4 comma 4. But instead of calling this function, if you do something like this, print of output, this should raise an error, says name output is not defined. So what it says is there is no variable called as output, but we can clearly see there is a variable called as output. So what's happening is output is a local variable. That means this variable or this value is confined only to your function and not outside this function. So this variable cannot be accessed outside the function. So that's why we call this as a local variable. But let's say we have a value as x is equal to 10. Okay, so this x is equal to 10 is a global variable. So when there is a global variable, you can just print it within the function. Basically you can access this within the function or outside this function as well. So that's possible. So I'll say, so whenever this function is called, we print the output, which is the sum, and also x, right? So in this case, x is not defined within the function, it's defined outside the function, but this can be accessed within the function and it can also be accessed outside the function as well. So I can say print x, but the similar print of output won't work because, as I said, x is a global variable, okay, whereas output is a local variable. So local variables are accessed only within the function because they are confined to it, but global variables can be accessed inside and outside the function. This is very important because we may like face several errors because we would have misunderstood something. We may not seen that a variable is a local variable and not a global variable, and we may get an error saying that this particular variable is not defined. So it's very important to understand this particular difference. So a local variable basically means a variable that's present within a function, and global is one that can be accessed inside or outside the function. So always define variables you want to reuse outside the function if needed. Okay, whatever you mention within the function, it cannot be reused outside the function. So that's like the main aspect of it. So let's just do a quick recap of what we have discussed in this particular section. So to first we use the define keyword to define a simple function, and we have seen how we can call a function by its name, and we have seen how we can use parameters to accept input and do some operations on it. We have seen how we can pass one parameter or multiple parameters, or also have some default parameters that can be taken when the user didn't give any values. And we have also seen how to use return statements to store that value in a variable. And finally, we have discussed about like variables inside the function and outside the function that are called as local variables and global variables. So basically, functions make your code organized, clean, and reusable. And that is a huge part of they are like a huge part of like real world Python programming as well. Okay, so that is all about this section of functions. Up next, we will learn how to handle errors in your code, because let's be honest, mistakes happen, right? So let's discuss about error handling in the next section. The seventh section of this Python course is about error handling. Even the best code can go wrong. Users might type the wrong input or files might be missing. If you don't handle those errors, your program crashes. That's where try and except comes in. So they let you catch problems and respond nicely instead of crashing and showing that red colored error to the user. So instead of that, you can handle that gracefully and say that this is what is going wrong, or you have to do this differently, and so on. So that is all about error handling, and we are going to use try and except in order to do that. So let's see how we can do this in the hands-on part of this section. So in this Google Collaboratory notebook, I have created a error handling.ipynb file, and I have connected to my runtime session. Okay, so let's look at a simple example that can cause an error. So first, let's try to understand what is an error, like when we run a Python code. Okay, let's try to understand that. So let's consider this simple example of getting an input from the user. So we have already seen that you would get an input from the user by using this input keyword. So let's say that it is a number, enter a number, and we know that when we use input, even it's a number, it's going to take it as a string. So we would convert that string into an integer using this int keyword, right? So that's what we have. So basically the user should send an integer value and we try to convert it, right, using this int statement. Okay, so you entered number. So in this case, I enter a number as 10. So that's going to get converted into an integer value of 10, and it's printing it. But what if the user, instead of sending, or instead of entering a valid number, they are giving some invalid input? Let's say instead of entering a number, they mistakenly like providing their name. Let's say I'm giving this, instead of like writing a number, I'm writing my name. So now it says invalid literal for int with base 10 set. So basically what it says is int cannot convert these string values. Rather, it can only convert the numerical values that are given as strings into the integer values, right? So basically in this case, you cannot pass a string or some other value. So it should be a valid number that int can convert, right? So let's say if the user types hello instead of a number, it crashes with this value error. Okay, so the program stops completely, and it is not good for user experience if they just like see this red colored error and the error message and so on. So that's why we have to use this try and except block. So I'll create another text cell, and here let's say using try and except. Okay, so now let's consider another code block, but slightly differently. So in this case, we have a try block. This is like the same code that we had previously, but it is present within the indentation within try. So what happens is, if the code executes successfully, so we get a value from the user and we print the number. If something went wrong, if they didn't provide like valid value in the input, then we have this except block that's going to say, oops, that's not a valid number. Instead of giving this error message, it's going to give this kind of like like reason to the user on like you cannot pass this, instead of just sending this plain error to the user. So that's the idea. So when I run this, let's say I'm giving a valid number as 10. So now it works fine. The except blocks doesn't run. Only the try or the except block will run. If something fails in the try block, then only like except block run. If everything runs successfully on try, then except is like not called at all. Whereas if I run this and the user again provide a name instead of the number, it's not going to cause this value error. Rather, it's going to say, oops, that's not a valid number, because what we have said is, so you should try getting the value from the user, and once they have given that value, you have to convert it into an integer and print it. Whereas if they have not provided a valid number, in that case it would raise a value error. So we anticipate that and say that create this exception or raise this exception, like whenever it's a value error, instead of like raising this value error, just print this, that it's not a valid number. Okay, that's about it. So this try, so this like Python runs this try block, and if an error occurs, it jumps to the except block. So value error is the specific type of error for this invalid int conversion. Okay, so now instead of crashing, your program handles it gracefully and say that, this is not a valid input that we can get, instead of like just like plainly giving a output message to this. So this is how you can gracefully handle the errors. So here it specifically handles value error, right? But you can also make it catch a generic error message. Like in this case, if it's not a value error, then this except is not printed. Still you would get an error because it's not a value error, but it's a different kind of error. So we are going to look at catching any errors. Okay, so this is the next third point that we are discussing. So catching any type of errors. So for this we can make this generalized. So instead of saying except of value error, you can simply say print number result in, and then you have to say like except this is the error. Okay, so basically we are like the user enters a number, input like a number. So if the user is giving the value as Sid, it tries something went wrong. Or if the user gives the value of enter a number, here if they give 0, it is also not valid because you cannot divide a number by 0, right? It is also a different error, but not a value error. In this case, it is actually an integer. 0 is an integer, right? It's not going to raise a value error, but it's a different error. But if I use this value error, let's see what happens. Except value error, and when I provide the name as Sid, it's going to work. Something went wrong because it's actually a value error. Whereas if I give the value as 0, it says 0 division error, because there are different types of errors may occur. So in order to capture a common errors or like any errors in general, you can just like remove this type of error that you're checking and you can run this. Okay, but again the problem is this handles all kinds of errors, but it hides like what the actual problem is. Like if I put 0, right, it just says that something went wrong, but it hides like what that actual problem is. So only use it when needed, and it's better to catch specific error whenever possible as well. Like instead of just like saying this something went wrong and not giving any specific messages, it's mainly like not suggested. So rather there is also another way you can do this. So you can say except exception as e, something went wrong, and here I can just say string of e. So this is also used to capture any errors that happens. So here if I put it as sit, it's going to say something went wrong, and it says like what the error is. And in this case I can put 0. This also captures it, but it says like what the error is, division by 0. Okay, so in the previous case, if you don't include this exception as 0 and e, it kinds of fails, but just says like something went wrong. But if you use this exception as e, this error message is captured in this e variable. We are converting it to a string, and then we are printing it. So this is how we can capture errors like by using a general exception statement. So one way is just to use like a particular value error that you expect. In this case you can do that, or in this case a value error or a 0 division error may occur. So in that case you can have a generic error statements as well, but the better option is to have multiple except blocks. So here I can say multiple except blocks. So here if we know that these are the different errors that usually happens for this particular block of code, then you can like handle all those things. So in this case we have seen like two types of errors, right? So one is value error and the other one is 0 division error. So I can say this is a number that the user have to give, right? So if they give a string value, in that case this value error is triggered, and it says like please enter a valid number. So when I press this, it says please enter a valid number. If it's a 0 division error, that means 10 divided by 0 is not valid. If I put 0 here, then this except 0 division error is getting satisfied. It prints that cannot divide by 0. but if I put a valid number of, let's say 2, then it's a valid number and it would print the result. So this is how you can handle, exceptions like with multiple conditions. So basically value error when input is not a valid number, this is raised. Zero division error when the number was 0. Okay, so Python goes to the first matching except block and it runs this. So it won't run like all the except blocks, but whatever is matching first, it would run this. And finally we have another type of handling this on this finally block. So this is like we have try block, except block, and then we have this finally block. So there is also this finally block. It always runs no matter what, even if your code runs or even if your code fails and the exception is raised. In both the cases, this would run. So we have a try block, we have a except block, and then we have a finally block. Okay, so I'll run this. So let's say I am entering, enter a number, right? So I have to run a valid number, which is let's say 10. In this case, try block runs and print this number. Except is skipped because try ran successfully, still the finally thing would run. So we have a block in this finally block, right? So still it would run. So it says like this runs no matter what. Even if an error occur, right here, if I give my name, it should raise an error. In that case also this finally block runs. So now if we think about what the purpose of this, right, you can use finally to close files, stop timers, or clean up anything even after an error. Okay, so it's like when you want a particular operation to happen no matter what, even if the code is successful or if the code is not successful, in both the cases we want some action to be happening. In that case you can use this finally. As I said, like if you want to close a particular file, clean up something and so on. So in those cases it's like really helpful. Okay, so these are the different things that we have discussed, and I'll just give you a quick recap of what we have done. So first, like we have basically seen like what are the things that can go wrong. This is just one example, but again several things can go wrong, right, in a larger program. So we've understood like how error happens and how it is kind of represented to the user, and then we have seen how to use a try and except block. So in the try block we write the code that might fail, and in the except block we catch that errors and respond to it. So in this case we have caught this error, the value error, and said that this is not a value, like a valid number. And then we have seen like how to handle like any basically like different types of errors that may arise by having like a common generalized error statement, and we have seen like how to print that as well. And then the next one is like handling multiple exceptions that may happen. So that is about it. And then we have this finally block that's going to run like no matter what. Okay, so these are the few things that we have. So this is how you build programs that don't crash and that users can actually trust. Okay, so now that your code is safe, let's learn how to work with files. So reading from and writing to files is a superpower for every Python coder should have. So let's discuss about that in the next section. The 8th section of our Python crash course is about file handling. So far, everything we have done lives only in memory. But what if you want to save data or read from a file? That's where file handling comes in. In this section, you will learn how to open a file, read content, write new data, append to existing files, and use with keywords safely in Python. So these are the different operations that we will do. So let's see how we can do that. So in the Colab notebook, I have created file handling.ipynb and connected to the runtime session. So the first thing that we would do is opening and reading a file. Okay, so this is the first thing that we are going to try. All right, so let me maybe put a number as well to track the number of things that we are doing. So the first part is opening and reading a file. So here in Google Collaboratory, so here we have different things, right? So we have table of contents, you have like find and replace, code snippets, secrets, and so on. And here you would have a symbol, like a folder symbol. When you hover over it, it would say file. So when you click this, this is like the directory that we are working on. So here you can upload files, create files, and do kind of like file related activities over here. So you can just like click on this. So this is going to expand it, and here you can right click and there will be an option to create a new file. So when you click that, you can just name it. So maybe I'll just give a name called as notes.txt. So I'm creating a text file. Okay, so this is created. I'll double click this and it would open that file here. This is an empty file because we have just now created it, right? So here I'll just write something. Okay, so something like this, Python programming. Okay, save this and you can just like close this. So we have a nodes.txt file. You can again open it to see like the content of it. Okay, so now we are going to open and read this file. So let's say that you have this file called as nodes.txt exists in your machine as well. Let's read like what's inside it. So we can simply use this code snippet that I right now. So I can say file is equal to open. So this open as a inbuilt Python keyword that's used to open a file. So here we have this nodes.txt file, right? And we have this R. R stands for read mode. Okay, so file is equal to open nodes.txt R, and then when you say file.read, this file is opened in read mode. You can also open in write and different modes as well. So, but for now, it's about read mode, right? Reading the content of the file. So you open the file in read mode and you actually read the content using this dot read function. So you say file dot read and all this content is saved in this variable called as content, and then you print this content. Finally you close the file. Okay, so let's maybe recap this again. So R is like read mode, dot read reads the entire file as a string, and dot close would kind of like close files to free up the resources so that this file can be used by some other resources or apps and all that. And then like once we read this, we like print the content as string and then we close it. So let's run this. It should read this file and we know that the content within this file is Python programming, so it should print it. So as you can see, so it read the entire content present in the file and it has printed it as Python programming. So this is how you can read print the content of the file, and then this is how you can close it. Okay, so the next is the better approach to do this, right? Like a better way of doing this, because what if you kind of missed closing that file and that is like blocked by this Python program, right? So in order to handle this better, we have this with keyword that we can use. So this is about using with to read. Okay, so this as auto closing feature. So this is for auto closing. Okay, I'll make this one bold as well. Okay, now instead of following this code, I can simply say with open nodes.txt or same thing, read mode. So I'm opening it in the read mode as file. So it's like the same thing. Instead, we are just like using a with statement over here. With open nodes.txt r content is equal to file.read and print content. Okay, here you don't need to write this file.close, because once this with block is executed, it automatically closes the file. So no need for dot close and this parenthesis thing. File.close thing is not needed. So everything inside the with block has access to the open file. So it's like you can open the file, write something, and then like edit the content and so on. Like all this code that lives within this with block as access to the content of the file that we have read. Okay, so this is the same thing that we have, but it is like much more simpler because we don't have to explicitly close the file and so on. Okay, so that's about it. So the next thing that we are going to do is writing to a file. Okay, so the third part is writing to a file. So now let's create a new file or overwrite an existing one using the write mode or the W mode. It's again similar to what we have done earlier, but instead of R, I'm going to say W, which stands for write mode, with open output.txt, W as file, file.write. This is my first file. Python makes file handling easy. So if you open this files, we don't have that output.txt file, right? You can also refresh this and make sure it's not present. But the moment when you run this, it creates a file. If it's not visible in your session, you can just like refresh this again and you will see this over here. If you open it, you will see like the entire content. Okay, so basically your W is write mode, creates new file, or it would overwrite the existing file. If I run the same thing again, it would overwrite the existing file. And dot write method we have, right? So this writes like the string data to the file, and we have this new line character \n. This means like this line is like written as a new line. So this new line character will be present here. That means like whatever comes after this should present as a new line. Okay, and as I said, the main aspect of this is this doesn't add lines to this would simply overwrite it. Let's say this is my first file, but I say that, or let's say I'm saying that this is my second file, and here instead of Python, let's say I say Java makes file handling easy. So in this case, if I run this, you may expect that it should add these two lines here, but it doesn't do that. It would overwrite what's exists, like what's already present there. So every time you open a file in write mode with this, it erases the previous content. So let's see, I'm running this again. Now if I open this outputs.txt, so you don't see the previous line. So the previous lines are, this is my first line, Python makes file handling easy, and the next set of lines is this, right? But the previous lines have been like overwritten. So that's what kind of like happens here. So in order to add content to a file, instead of overwriting it, we can kind of like use append mode. Okay, so that's about the fourth part that we are going to discuss, which is appending to a file. So for this again, it's much simpler. So you just have to replace this W with A. So with open outputs.txt A as file, just use the same file.write. Okay, so previously we just had these two lines, right? This is my second file, Java makes file handling easy. So instead of opening it with W, we are opening it in append mode using A. So I'll run this. Okay, now we can just refresh, or you can close it and open it again, so that that change is like reflecting it. Now you can see it didn't overwrite the content, but it just like added a new file, added like a new content to that file, because we have used this append mode. So this is how we can do this. We can also read lines line by line. So this is for it. So in this case, I have this outputs.txt. If you use this method, right, this entire content is read as like one string, right? But let's say you want to print each of these lines separately. In that case, you can iterate this file over a for loop and then just like print this. So basically, using a for loop, we are going to loop through the file object that we have created using the with statement. So this file object gives one line at a time, right? So when you iterate over this file object, it's going to give one line at a time. And this dot script, basically it removes the new line at the end of each line, so that some empty characters, empty lines are not like printed. So that's the purpose. See, so first line is, this is my second file. When the for loop runs for the first time, the file object provides the first line, this one, to the for loop. So this line is printed in this print statement. In the second line, like Java makes file handling is like the second line is printed, and so on. So this is how you can print lines, or basically print lines like line by line. Okay, and another interesting kind of like a bonus thing I wanted to show you is like checking whether a file is present before opening it. Okay, so here let's say I'm trying to open nodes.txt. That file already exists, right? So here OS is the basically operating system, and this library is used for several purposes. One of those is like file handling and so on. So here we are checking os.path.exist nodes.txt. That means if this file nodes.txt exists, in that case open nodes.txt and then print its content, else say file not found. Okay, so basically if the file is present, it would read and print the content. If the file is not present, this code block wouldn't run, rather it would say file not found. So let's run this. So we know that nodes.txt is present, so it reads it and prints it. But what if it's not present? Okay, so maybe I'll rename this to nodes_1. We know that such file doesn't exist. So what happens is, it doesn't raise any errors, rather it would go into this else block and it would say file not found. Okay, so this is how you can use this OS library in order to check whether a file is present before just like trying to read it content, so that error is not raised. So that's how you can handle this one. So files not found. So these are some of the basic operations that you can do regarding to file opening and writing, reading, and so on. Let's do a quick recap. So first we have like seen open, file name, and mode. We have seen like how to open a file using this open keyword and mentioning like the mode over here, right? So we have read, write, and append mode, and we have seen that we have to always close the file. But we have also seen how to use with in order to do this auto closing part. And we have seen there's dot write and the dot read function to read a the content of the file or to write new content. And we have also seen like when we use w, it's going to overwrite the content, erase the entire thing and add new lines. But when you open it in append mode, it's going to add new lines to this. And finally we have this thing of how to print this line by line and so on, and then checking whether a file exists before reading it, so that we it doesn't raise any errors and so on. So these are the different basic file operations that we can do. So in the next section we will build a real life mini project using everything we have learned so far to bring all the pieces together. So let's apply your knowledge in a hands-on real world app. So let's meet in the next section. In the section 9 of our Python crash course, we are going to build a Python mini project where we will be building a to-do list application. We have learned all the building blocks so far: variables, loops, conditions, functions, and files. Now let's bring all these things together and build something real. We will create a simple to-do list app where you can add tasks, view tasks, and save them to a file. This is how real programs are made, by combining small concepts into something useful. So let's see how we can do this in Google Collaboratory. So before going into the coding part and explaining you that, right, so I have all the code here ready. So before doing that, first I'll show you, how this application works, what are all the different features that we have, and like the main concept of this. Then I'll explain you the code and like how the entire thing works and so on. So basically, we are building a simple command line to-do list app, and it runs in your terminal and helps you manage your daily tasks just like a basic personal assistant. And these are all the different features that we have. So we have this add a task feature. You can type in a new task like buy groceries or finish homework, and it will be added to your list. So this task is stored in a list in memory. Later it is saved to a file when you exit this application. Okay. And the second feature is like view all the tasks. This option shows everything currently on your list, like neatly numbered. If there are no tasks, it says like there are no tasks available. You will see each task on a new line. Okay, like let's say all those buying groceries or homework and all those things are listed properly in new lines. The third feature that we have is remove a task. If you are done with something, you can remove it by entering its number. Let's say buy grocery is in the first line with number 1. You can just put that number 1 and it will remove that from the list. Okay. And the fourth one is save tasks automatically. So your tasks are not lost when you exit the application. We save them to a file called as tasks.txt automatically. So when the app starts, it loads any previous tasks from the file. When you exit, it writes all the current tasks to the file again. This means your list stays up to date even between runs of this application. Okay. And finally we have a smart menu with input validation. So the app keeps showing the menu, like all these different options that we have: adding task, removing task, and like viewing task and so on. So it keeps showing this menu until you choose to exit. You also have an option to exit as well. If you type something invalid like hello or some number that is not valid, it will warn you and show the menu again. So this is handled using a while with a true condition loop. So your app keeps running until you choose to exit. Okay. And how all these things work is like a list called tasks store all the current tasks. When you run the app, it first tries to load the tasks from a file that we have saved. You interact with this using a text menu that would list like all these different options. That is also handled by a while loop, and your input is also validated with several if, else, and else condition. And whenever you exit, the tasks are saved back to the file. So we use function to keep things modular and organized. So basically, like we are using like all the things that we have learned so far. So I mean, this app may seem small, but it brings together almost everything that we have learned so far in this course, like variables, list, loops, conditions, functions, file handling, error handling, etc. And most importantly, it's useful. You can literally use it to manage your day right from the terminal. Okay. So those are about the different features that we provide in this application. But now let's see like how this works. So I don't have any file right now, as you can see, but once I start working on this will create a new file over here. And the other important thing about Collaboratory is if you close this Google Collaboratory session and open this again, that file won't exist. But if you run it on Jupyter Notebook, this runs again, because this is not a persistent storage. This is only a temporary storage, Google Collaboratory. So like you start the session, you run it, but once the session is stopped, you won't see this file again. but again, it's not intended to be used on Google Collaboratory, to be honest. So rather, if you run this on Jupyter Notebook, we have already seen the how to use Jupyter Notebooks or PyCharm. So there, if you use it, that file is going to stay. So I wanted to tell you about that as well. Okay, so now let's see how this thing works. So when I run this code, it gives me the menu bar. So this is the menu that I told you about. So when I put number 1, it would show me the list of tasks that's available. 2 is for adding a new task, 3 is for removing a task, and 4 is for exit. If I don't want to do anything, I can simply press 4 and that's going to exit it, and it says task saved, goodbye. But we don't have any tasks there, right? So if you open this, there won't be any tasks. You can still keep it, or you can just like delete this as well. So that's good for us, because again, we can test it from the start. Okay, so now I'll run this again. I'll press this 1, which is to view the tasks, right? But we don't have any tasks, so it says no task set, and again it shows the menu. So this keeps showing the menu until you press 4 to exit it. So now let's say that I press 2 to add a task, and it says enter new task. I say that learn Python programming. This is my first task. Okay, so I've added this task, and now what I'll do is view the tasks that I have. So I'll press 1 and it shows the task that I have, which is learn Python programming. And the next thing that I have is, let's say I want to add another task. So I again give 2 and I have to enter a task. Here I'll say learn C programming. Okay, so these 2 tasks are saved. Now I can again give this 1 and it says learn Python programming, learn C programming. And again, I can just like exit this. Okay, so it says task saved. So what happens is it basically runs on your memory, but once you are closing this, all these tasks that you have added are saved to this particular file. So we have basically used whatever we have learned with the loops and mainly like the file handling to persist the storage into this task.txt, so that it's like living beyond like this program is executed. So when I start this particular cell again, right, so it reads this task.txt and continue from there. So now I can freshly press press 1, which is view task, and it would still show like the previous task that I've entered, because now it loads from the tasks.txt file. If I want to remove any task, I have to give 3. So when I give 3, it lists like the number of tasks that I have learn Python programming, learn C program, and it says that enter the task number to remove. If I want to remove the first task, I have to give 1. Second task, I have to give 2. So let's say I want to remove the second task, so I give 2 and it removes it. Again, if I want to view the task, I can press 1 and you can see that the second task, C programming, has been removed. I can press 4 and it would exit. And again, I can run it, view task, or exit it, and so on. So this is how this entire thing works. So you basically have the option for view task, add a task, remove task, exit, but we have also added input validations. We have also added like error handling and so on, and mainly the file handling point in order to persist the task that we have kind of like taken in the list and so on. So that is how this entire application works. So I hope that by now you know what are all the different features that we are providing. Now let's go through the code and understand like the different functions and like basically what we have done in order to accomplish this. Okay, so that will be the next part. Now that we have discussed the different features that we are going to add in our to-do list application, let's understand the code. By the end of this breakdown, you will understand how everything works. Lists, loops, variables, file handling, and functions all in one app. So in order to get started from first, I'll just remove this task.txt. This will be created once we run this again, but let's learn this code without this file, so that we can start from the initial part. Okay, so first we have created a function over here. So we begin by defining a function called show underscore menu. Every time this function is called, it prints the options the user can choose from. So the view tasks option, add a task option, remove a task, or the exit option that would stop the application and it would like exit from it, right? So the new line that's present over here, this adds a blank line before the menu, right? Because once a user has added a task, again we have to show the menu, right? If we don't have this new line, that it would like show this menu on that same line. We don't want that, so that's why we have this new line like at the start of this to-do listing. The print statements that we have here show the choices for view, add, remove, or exit. exit, and this keeps our code clean and reusable. The reason we have this in the menu is that we have to keep repeating, right? So we have to keep repeating showing this menu. So instead of writing the sprint statements again and again, so we have created a function, and repeatedly, like, we would show the menu in a loop, so that like whenever they perform a task, so this menu gets showing up because it's in a loop, and we have created a function. So we are using this function within this while loop that we have. Okay, so the first part is all about creating this show menu function that gives a list of the different options that we have in our application. All right. Next, we define the load tasks function to load saved tasks from a file called tasks.txt. So we use a try except block over here as well. So we have this open tasks.txt comma r, this, which is basically the read mode, right? So this tries to open the file in read mode. If it exists, if the file exists, we loop through each line and add it to a task list. So here you have this task, right, which is basically a list that we will create later. This is a function, so we haven't provided this list yet. And then we have this dot strip in order to just like remove that new line that we have created, like in this particular part, like when we add a task and all those things. So if the file doesn't exist, like the first time you run it, the file is not there. So in that case, we exception would be raised. This file not found exception would be raised. So whenever this exception is raised, we pass. That means like it would just like skip this and like go to the next iteration of the loop and all that. Okay. So basically what we are doing is, if this tasks.txt file is present, read this entire content line by line, because as you can see, we are iterating over it. If you remember, we have done this in our files section. So we used a for loop to iterate the lines, like line by line, the content present in a file. So you read each of these lines and save it, or basically append it in a list called tasks. So we have seen that you can append data to a list by using this append function. So that's what happens here. So the first function would show the different menus that we have, and the second function, this is used internally to just like add the tasks that the user is giving in a list. So if the file is not there, that means when the application is starting for the first time, the file is not present. So in that, we are just like simply parsing it. Okay, so this is the second function that we have. So the next function we have is the save tasks function. Now we define the save underscore tasks to save all the current tasks back into the file. So we have this W, which is for write mode, right? So W mode overwrites the file. We loop through each task and write it back to the file. And again, the new line ensures that tasks goes on a new line. So that's the main thing. So we overwrite it because in a particular session, the user may remove particular tasks because they have already completed it, right? So you have to override this entire thing with their latest updates. They might have removed a task, or they might have like added a task and so on. So this save task basically saves like all the tasks like towards the end of the session. As you can see, like when they exit, right, when they click on this 4, the current update, the latest state of like the list of tasks and the remove tasks, everything is like updated in this task. So these are the three main functions that we have: show menu to show the different options to the user, load task to read it from this task.txt file. For the first time it would pass because the file is not there, but in the later runs it would read it, so that there is a continuation, so that I can run this, add 4 tasks, I can exit the application. Then when I open it again, right, so it should read from that same task and continue where I left. So that's why we have this load task. And then we have the save task function to save the current state, like all the tasks removed and added to that particular file with like a new line to it. Okay, so this is where we are initiating the task list. Okay, so we initiate this task list, which will later be we would like append it over there. And then we have this load underscore task, which runs when the application starts, where like for the first time, again, it doesn't mean anything because an exception would be raised and it would get passed here. But in the subsequent runs, it is just to load the task from there. Okay, so we will start with an empty list named task over here. Then we call this load underscore task right away. So any previously saved tasks are basically loaded at the start of this application. And then we have this main loop here. So we have a while true. So basically it's an infinite loop, right? Because it should keep running until the user gives an option called as 4, which is to exit, right? So if they don't give that, it should keep running so that they can add or view tasks and so on. So we enter an infinite loop because it is always true until the user has like exited it. So if they given 4, we have a break statement, so the loop would be stopped, right? We have discussed this in our while loop section, in the for loop section. So we enter an infinite loop, so the menu keeps repeating after each action, like after adding a task or after removing the task, we keep showing this menu show underscore thing, and then choice. So this is the main part of this. So at each iteration after adding a task or removing the task, this loop should run, and it should basically show the menu, and it should show the choice to add the user's option, right? So this part is what we have here. So this is the menu and this is the user input to give some choice, right? So these two things are coming from here. So this is my main while loop. And then we have different options to choose from, the 4 options that is present in the menu. So all these are kind of chosen by the user using like the different if and else if and else blocks that we add. Okay, so view task, add a task, remove a task, and exit. So let's try to understand this. So the option 1 that we have is view tasks. Okay, so in this case, if the user chooses option 1, we print all the tasks because it is for view the task, right? So when the user chooses 1, we print all tasks. If the list is empty, that means at the start of the session, or if they have removed all the tasks, so that's when the list would be empty. So we show a message saying that no tasks yet. So that's when this condition would be saved. 2 cases: at the start of the application, when there is no tasks available, it would show no tasks yet, or if they have removed all the tasks also, it would show that. Okay, otherwise in the else condition, it would enumerate over it, and then just like say that first task is the second task is this, and so on. When you use enumerate, it's kind of like gives the index of the value as well. Here we have start is equal to 1 because we don't want to show the task list as 0 is learn Python programming, 1 is learn C programming, and so on. Just in order to avoid starting from 0, we use like the start is equal to 1 just to have the values like start from 1. So it's like not that much complex. So choice 1 is like view task. If nothing is there, then print that no task yet. If there is some task, print it with the serial number, and the serial number should start with 1. So that's why we have this in the print statement. This task is like those individual tasks that we have created, so it would be present over there. And then we have a option to option, like in this option 2, which is add a task. Okay, so if the user choose option 2, we ask for a task, right? So we are asking for the input, user input, using this input keyword, right? If the user chooses 2, we ask for a task and then add it to the list using dot append and confirm if this has been like added. So we say that new task is equal to input, so the user gives his input. Let's say 2 is learn Java or something, or let's say buy groceries or something. So when they give that, we add this to this tasks dot append and basically append this new task to this initial list that we have created, and print that, give a confirmation that a task has been added. And the option 3 is removing a task. So how we would remove a task is, first we display all the tasks in order. Let's say first is learn Python programming, second is learn C programming, third is buy groceries. We would list that and ask the user to say that which task do you want to remove, 1, 2, or 3, and they would say, let's say remove 2. So if they would provide like 2 as the input, and then we would remove the second task, which is like learn C programming. So that's how this entire thing works. Let's understand this. So if the user chooses 3, right, we first check if there are any tasks to remove. First of all, if the list is empty, we display a message saying like just like no task to remove that. So we would just say that. If not, we show the list with numbers. Like let's say if there are 3 tasks present, we would like display those lists with numbers. So first is like when there are no tasks, we say no task to remove. If they have some task in it, we list the task in this particular for loop, just like the way we have displayed the task in the first step. So we would display that and ask the user again to give an input to say like out of these 3 or out of these 4, which number task I should remove, 1, 2, 3, or 4. So the user would choose from like any one of these tasks. So once they give this, let's say they give the value as 2. So this value 2 has been converted to integer, just like the way that we have did in our previous part of the course. So this value is getting saved in this remove index variable. So if we check if this is less than or 0, length is less than 10. So we are just like checking if it's like present in that list. If it's present, then pop it out of the list. So pop, basically what it does is, if there are 3 let's say there are 3 tasks that are added to the list and the user has given the value as 3. Now we remove it from there, and that removed task details. That string is stored to the variable called as removed, and then we print a statement saying that this is removed from here, this is the task that has been removed. The reason we are subtracting this one is because we have started with 1 and not 0, but we know that list understands only the index with 0, right? So we need to revert this back saying that basically when the number task is 1, it means the actual index is 0. So in order to compensate to that start with 1 instead of 0, we are like kind of subtracting this. So that's the thing. And if it's like both are not satisfied, that basically means like that's an invalid task number. In that case, we would print it. And finally we have this 4, which is like basic exit operation, right? When this 4 is called, we kind of like call the save task, which is like save the current task information to this file called as task.txt. So this function is called, and then we would break out of this while loop. So this is how this entire thing kind of works. If the user has provided some invalid choices, we would say that, invalid choice. If it's like out of these 4 choices, and it would say invalid choice, please try again. So this is like the eye level overview of this. So first you show the menu, and you have this load task that is called at the start in order to like read from any of the previous session that has been stored in this tasks.txt. And then we have save task. This is called like whenever the user exit the application. So we initiate a list, and then we call this load task to like load the previous listed task, and the main while loop. So when the while loop runs, we display the menu, and always ask the user to give a choice. So if they give 4, it's going to save the current state and it's going to exit it. If it's 1, it's going to display all the tasks. If there are no tasks, it's going to say no tasks available. If not, it's going to list all the tasks. Second is like adding a new task. So we use this input to get the user's input and then append it to the list. Once they exited, this added task would be saved using the save task function that is called in the 4th choice. And then in the 3rd is like probably like the bigger one, but it's also like pretty simple. So when there are no tasks available, we say that no tasks to remove because it's empty. The else case, if some tasks are present, we say that these are the tasks that are available, which number you want to remove. So we ask that. Once they give that, we remove that and say that this particular task has been removed. If not, we say that this is an invalid task number. And finally 4 is pretty simple. So you save the current state and you break out of that while loop in order to complete this particular execution. If it's like the choice is not valid, we say invalid choice, please try again. So this is how this entire thing works. So it's pretty simple. So once like you just write it by yourself, even by viewing, you will kind of get a good hang of it. So maybe I'll just like run this again. I'll show this to you how this works. Again, I've not created the tasks.txt yet, so it would be like fresh. If I give view task, it would be no task yet. So now I'll say add a task. New task is, let's say, buy groceries or something. Like we can just give any things over there, right? So I can give exit, or I can just like add another task by giving 2, and I can say like say do homework or something. Okay, so you can just like keep doing this and you can exit it. Now if you run this again, as the tasks has been saved with the tasks that you have provided, so like buy groceries, do homework. So if you run this, that would start from there. So if I press 1, that's going to say like your tasks, call these tasks, and like all those options and so on. Okay, and maybe the next option is like you can just like simply exit it. So this is how this entire thing works as well. So I'll share maybe like all these notebooks with you as well. So you can just like go to the links and like access this, or I'll be giving you a folder link, Google Drive folder link, so you can open that. That would have like all the Google Colab notebooks that we have worked on. So you can just like open it, so that would automatically open it in the Google collaboratory environment, and you can work on it. If not, you can also like download this from here. So you can download this as like a .iponb file as well. So you will find the link of the all the code files that we have worked on in this video descriptions. Like you can check this out. Okay, so this is how you can build this mini project where we have built a simple to-do list application. So please try this out. Again, as I said earlier, Google Collaborator is a session based environment. So the next time you close it and open it, you won't see a task.txt. So what I would suggest to you is like you can just like download this IPYNB, open your Jupyter notebook or Jupyter lab. There you can upload it and then you can work on it. So basically this task.txt gets saved in your local machine, so it won't get deleted. So that's how you can work on it. So that's about this 9th section of building a mini project in Python. So in the next section, I'll give you an idea of like what are all the things maybe I'm planning depending upon this course that we have, and like after this, like basically what you can learn and all those things. Okay, so let's see in the next section. Congratulations, you now know how to write Python code, use logic, handle files, and build a working app. Here's where you can go from here. So you can learn object-oriented programming with Python. So learn about classes and objects, or you can work on web developments. You can build websites and APIs with Python libraries like Flasks and Fast APIs, or you can go in the route of AI and automation. For AI, you can start with machine learning, or how to use Python to train and build models, or if you're interested in generative AI, how to use the OpenAI APIs, LangChain, all those libraries and so on. You can try all those things as like moving on from Python. So yeah, that's about it. And in the upcoming crash courses, I'm planning to make courses on Git and GitHub for beginners, building APIs with Flask and Fast API, Docker, and so on. Let's say some on generative AI, like shorter crash courses on RAG, agentic AI, like other topics as well. So please show your support. If this crash course helped you, like this video, share this with your friends, subscribe for more beginner friendly and project oriented learning. That's the final words. I just wanted to tell you that you took action, you showed up, and you finished, and that's what matters. Keep going, and I'll see you in the next one. Thanks for watching. Bye.